back?
I am. Should we go ahead and get started here?
You want to give 2 more minutes so
Sure.
that, yeah.
Sure. You tell me. Yeah, I'll pause the recording until then.
Yep.
All right, very good. So we'll go ahead and get started. So welcome everybody to today's session. My name is Josh Brothheim. I am the training manager at Sumo Logic, and I'm going to be leading today's session. Hopefully you were able to join us yesterday for John's portion of the class, where he went over fundamentals and I believe search mastery yesterday. And so what we're going to do today is we're going to go over 2 different topics. For the first portion of the morning, we're going to go over cloud security monitoring and analytics. So we're going to look at the query language and how it can be used from a security standpoint. We'll be doing a certification as well. So we will be taking an exam shortly. So for the next 2 hours, we'll be doing some labs, mostly labs, pretty interactive today. And we'll share those credentials shortly. And then we'll take a break. We'll a little break for lunch, and then we'll come back and we'll talk about observability within Sumo Logic, using some cool features such as tracing and root cause explorer that can really, you'll see how well they help provide that observability story and get an understanding of what's occurring in your systems and your environments. But let's go ahead and get started. So as mentioned, feel free to take yourself off mute if you have a question. Also, if you want to use the chat as well. And let's get started. So for course agenda, as I was starting to describe, we're going to do a little introduction right now, kind of knocking that out. I'm going to do a quick demo just to show you some of the features that we are referring to when we talk about security in Sumo Logic. And then we're going to get into labs. So as you can see, the bulk of today is going to be labs. 1 through 5, we're going to take a little break and do more labs and then take certification class. So the labs are, I think they're fun. They're more interactive, just a good way for you to get hands-on experience. So we're really going to dive into those very, very quickly. I want to talk a little bit about Sumo Logic just as a whole. You may have seen this slide yesterday, actually. If you did, that's okay. But just want to go over quickly kind of who we are and how Sumo Logic fits into the whole picture of observability and continuous intelligence and all that kind of stuff. And so what we're finding is that everybody's finding that digital transformation requires continuous intelligence, and businesses are leveraging a new category of software called CI, or continuous intelligence. And this is real-time analytics and insights from a single cloud-native platform across multiple use cases that can help speed decision-making and drive world-class customer service. Using our analytics across your operations, security, business, and global intelligence data, that's going to provide you continuous awareness to impact your results. So for example, with operational intelligence, you or we can figure out, are your systems up and running? What is your MTTI and MTTR, those mean time to identify, mean time to resolve, those more critical indicators or metrics every day? Those are really becoming more and more important. From a security intelligence standpoint, and we're going to be going through this quite thoroughly over the next 2 hours, but using Sumo Logic to understand, is somebody using root access in your system? Is a person logging in from multiple locations simultaneously? Has your SIM picked it up as an actionable item? These are all things that Sumo can help with. And like I said, we'll really be focusing on that today, the security intelligence. Business intelligence. Sumo is great for letting you know what pages are people frequently viewing on your website. What are they ordering? If you ran a marketing campaign, was it successful or not? And then global intelligence is that how are you doing compared to other companies and observing your data at a worldwide level. Using your data-driven intelligence, to extract those real-time insights and add from business volume the massive volume of machine data that's generated in the forms of logs, metrics, events, other information. And these are going to come from your all different feeds, from your apps, from your microservices, from your cloud systems, your infrastructure. As we can see here, some other, all your data is coming from all these different just environments around the world. Now, our analytics in here are going to help you. There's going to be multi-tenancy, sorry, where the information is going to be very secure. We have advanced analytics built into the system. We have the ability to interact with third-party services such as Slack and Twitter and Discord, and utilize some of those webhooks to communicate outward, whether it's internally or externally, but add that communication value. Let's see, what else do we support for our analytics? Talking about machine learning, APIs are fully supported. We don't go really into APIs in this class, but they are supported and quite thoroughly documented. Advanced analytics, we're certainly going to look at some of those advanced analytics today. And so we'll both get a good feel for that. And once again, that security and monitoring that we're really going to be focusing on today. And then finally, on this last slide here, who can benefit from Sumo Logic? Well, everybody can. Whether you're a part of DevOps, whether you're a part of engineering, IT ops, customer success, etc. These are all people and members of the team or organization that can utilize this information and become more valuable. All right. So that's really, oh, and then talking about the security intelligence solutions, getting a little more specific here. So on the left-hand side of the screen, what we're going to talk about is the ability to utilize Sumo Logic for audit and compliance. Let's get my little, there we go, my little graphic going. When we're talking about audit and compliance, we're talking about a highly scalable and secure platform that's going to store all your data. It's also going to be backed by those numerous certifications and attestations. I didn't really reference them on the previous slide, but we have our HIPAA, our SOC 2, our FedRAMP. Some of those are global certifications, some US based, all pretty important. And so that's certainly a part of utilizing Sumo is that validation that it is backed by all the certifications. Your data collection is scalable, and then using a bunch of out-of-the-box pre-built compliance apps, you can experience some rapid time to value for your security audits. Now, today, we're not talking about audit and compliance specifically. It's a portion of the security intelligence solution. Sumo does a great job with it, but that's just not going to be the focus for today's discussion. What we are really going to be focusing on today is this middle section, the security analytics. Oop, went too far. There we go. And with the security analytics, what we're talking about is the ability for you to build on the intelligence that's in Sumo by performing deep searches using your data for correlation, which is going to be required for analyzing your security event logs, using our pre-built dashboards and establishing alerts for monitoring. Sumo Logic is also going to provide some of that advanced analytics that I mentioned earlier for troubleshooting. We're going to look at a couple examples such as integrated threat intelligence using CrowdStrike threat intel feed, which is a great source of data, and we'll talk about that in more detail. Detection and alerting on anomalies using outlier detection. And I think we do a lab with that today. We'll also talk about log reduce, log compare as a method to utilize for machine learning technology to really take a bunch of large data sets and sift through them. And you'll see how that log reduce and log compare work. I'm hoping you've seen that feature before in Sumo, hopefully at a previous class. If not, of course, we'll go through it quite well today, but it's a really pretty helpful feature in Sumo and quite an easy one to utilize. And then finally, when we're talking about security intelligence solutions, we do have Cloud SIEM. Now, we're not going to be focusing on Cloud SIEM today. That's something we can do down the road and will do down the road, some classes on that. But when we're talking about Cloud SIEM, what we're talking about is the security intelligence of continuous threat correlation that's going to allow you to go back weeks versus just hours across your on-prem cloud, multi-cloud, hybrid cloud, whatever data sources, using these out-of-the-box rules. With the Cloud SIEM, it gives you a streamlined security analyst workflow. As you can see just by the image on the right, it has a kind of a heads-up display that allows you to really interact with the data, interact with the records, the insights with the system, and a more of a top-down display versus pure query language based, which makes it easier to use. It's pretty neat as well. Like I said, but we'll be offering classes on that shortly, another month or so. But today we're focusing on that security analytics portion, this middle portion here. All right, 1 or 2 more slides, and then we'll start to get rolling along further. So with this slide, what I just wanted to show is the fact of what we're really drilling into today when we talk about security analytics. So for this class, and when we talk about security analytics, what we're really referring to is the ability for you to use and create searches, dashboards, apply advanced search operators to provide you with your continuous intelligence across all your applications and infrastructure. Searches are going to be easily created to query your data, and then you can create dashboards using your queries. And we'll go through a few labs doing that. Advanced analytics can also be applied as you use the search operators, which will allow you to detect, investigate, and respond by looking at anomalies, filtering on the specific events when they occur, and predicting future trends. So we'll be doing on the left-hand side of the screen, those searches. We'll be creating, I think we'll be creating a few dashboards, which are going to be sort of composites of those searches in a visual output. And then we'll be utilizing some of those advanced analytics, some of these that are right here, and a few new ones to you. All right. Any questions so far? Hopefully not. Oh, actually, either way, hopefully if there are, of course, please ask, but hopefully pretty straightforward.
Yeah, I have a question.
Yeah, of course. Go right ahead.
Typically, for a SOC opportunity, which solution should we propose, like the cloud SIM or the security analytics platform? Because if we are comparing with, say, QRadar or probably Securonics or any other tool, if we have to compete in the market, so which solution should we position?
So Cloud SIM is positioning to be that product or that role, so that it's designed for that SOC analyst. Really, that's what it's really intended for. But what we're going to show today is the ability to do some of that stuff through Sumo Logic as well. Suresh, any color you want to add to that, or?
Okay. So is the question from the perspective of how do we position Sumo Logic against a couple of other vendors available in the market today?
Yes, exactly.
Okay. So there are a lot of unique areas where Sumo Logic scores against the traditional players. Sumo Logic as a SIM, we are born out of cloud, and we support all the cloud environments available in the market today. The predominant 3 public clouds, AWS, Azure, and GCP, we support all of them. We also have unique mechanisms by which we can ensure we can cost effectively bring in all the data of the customer. So when customers want to ensure their security posture, they don't want to have any dark spots, blind spots, etc., then they need to bring in all the data to continuously evaluate their security posture. So this is where Sumo Logic can help you to a greater extent. We have a highly scalable cloud platform which can ingest terabytes and terabytes of data into the platform without any stress. And we also have a zero loss model. We provide a credits-based pricing, very similar to the way AWS provides pricing. So all this ensures that customer can cost effectively own the platform, and they can bring in all the data into the platform without really having to stare at a huge bill out of the logs, right? So these are a couple of things from the platform side of it. We also have ready to use out of the box content using which they can quickly integrate their various different sources of data. We also provide a free CrowdStrike threat integration. Standalone, this threat feed costs around 80K, whereas we provide that correlation to customers completely free, right? So we also have an advanced Cloud SIM enterprise module, which focuses on reducing the alert fatigue. It has an auto correlation, and it also provides you workflows, etc. It's a very advanced module available within the Sumo Logic SIEM offering. So we can work with you if you have any opportunities where you are seeing a competition out there. Feel free to reach out to us, and then we can actually work with you to see how we can actually position ourselves against any other player available in the market today. Given the Sumo Logic's platform's advantages, the cost advantages, the platform advantages, the pre-certified platform that we have, and then the unique pricing models, out-of-the-box integrations, we can easily win against the major players available in the market today. So let's take it on a case by case basis, but these are
No,
the
that's
general
fine.
concerns this is going to work.
And only my question was like, since you have shown two solutions, I just wanted to know what is the differentiation in that, so that when we talk to customer with respect to any other competition, so which one should meet his requirement, right? So whether if we are talking about correlation or alert triage and all those things, then probably if it is not available in the standard platform, then definitely cloud SIM is the one which we should position, right? So where that is all threat hunting, everything, all these things are required in any SOC platform.
That's right. So there are advanced capabilities in the cloud the cloud SIM enterprise module. There are base features which are available in the cloud SIM module. So we need to see what is required for the customer. Obviously, the enterprise module comes at a higher pricing because of the additional features, etc., which is available. With respect to sizing the solution, with respect to comparing, that would be a separate discussion. Let's focus on the agenda for the meeting today, which is about the cloud SIM. We did a workshop yesterday for a cloud SIM enterprise module, but we can actually walk you through the difference between these two platforms, etc. That can be taken as a separate discussion.
Okay.
All right, very good. Thank you for the question as well. So let's go ahead and let's take a look at this demo that I wanted to show you. So what I have here, yep, here it is. Let's make this a little bit bigger. So what I have here is a demo that I want to walk through. In this case, we're going to utilize AWS data, but as the questions come up, we do have multi-cloud support. Just in this example, I'm going to use AWS. So what I have here is my dashboard, and let me go ahead and make this, let me zoom in a little bit more. That should be better, good. All right, so what I have here, sorry, is my dashboard with security overview information. And so what I'm getting in here is a snapshot, or not a snapshot, but a view into all different data that's occurring, in this case in AWS, and providing me that output through a simple view that I can go ahead and just visually understand. So for example, right here, I have my SSO and non-SSO login located all around the world. So I'm seeing where my users, my visitors, my customers are coming from and logging in from, might have access from, whatever it might be. Certainly, if this is something that I don't suspect or is unexpected, then this might cause me to think there might be a security incident. For example, if we're not doing anything related to Australia, and I have people logging out of Australia, that might be curious. Now, it doesn't mean it's a security event, but it is starting to give me that insight of where these locations are, where these logins are occurring from. In the middle section here, we have the threat intelligence panel, and we're going to do an exercise with this. But this is taking advantage of that CrowdStrike data that Suresh just alluded to. And that data is quite expensive. It's $50,000 US dollars, maybe more now. But we give it to you for free. And so what it is CrowdStrike is a industry leader in threat intelligence. Well, we do a great job with logs and analytics and all that. Their job, their company is set aside to see where threats occur all around the internet. How do they spread? Where do they start from? How do they attack? All that kind of stuff. And so what we're doing here is we're taking advantage of that data and we're using it to look at, in this case, IP addresses and decide or determine if they are malicious or not. So this is telling us out of these IP addresses that we're looking at from the last 60 minutes, 100 of them have a high maliciousness. Now, if they do have a high maliciousness, that is something that we might be concerned with. We might want to blacklist those IPs. We might want to follow those IPs. We might want to, do whatever we want to do, but we're starting to get that information provided to us in a dashboard. On the right-hand side of the screen, we have suspicious login distances, and we'll do a lab with this as well. What we're seeing here is a user, Damon. And what the system is doing is looking at where Damon has logged in previously during, in this case, a 3-hour period. And what it's found is that Damon has logged in from an IP in the United States and an IP from Egypt in the last 3 hours. Now, Damon cannot physically travel between the US and Egypt in 3 hours. And so what this is indicating is the fact that this is suspicious. Now, does this mean that Damon is a malicious hacker trying to do something bad from the United States and Egypt? Well, maybe, maybe not. What it does tell us, though, is that he did try to log in from 2 different places during a time period. And then we, as a, whether we're a manager or an administrator of the system, might go to Damon's manager and say, hey, we saw that Damon is logging in from 2 different places within a small time period. Is that correct? And if the manager says, well, yeah, Damon's job is to test VPN access around the world, then this makes perfect sense and is completely acceptable. If we go to the manager and they say, yeah, Damon hasn't worked here in a month, and we find someone who is using his credentials and logging in from different places around the world, that becomes suspicious. And so that's where Sumo Logic can provide some of this information or all this information. And then we still need to kind of make some decisions about, is this bad, is this good? Certainly many ways to automate that decision making as well, but that is what the system is showing us. This is suspicious, and then we need to decide, is it something that we really need to investigate further or not? Let's see, a couple more charts here. We have, let's talk about this one right here, this VPC flow data volume. The reason I'm pointing this one out specifically is it's utilizing our outlier feature, one of our advanced analytics, one of our better advanced analytics. What the outlier operator allows us to do is allows the system to do rather, excuse me, is to take a bunch of data that's occurred already, look at it, look for normalcy in it, and look for variance in it, and start to let us know when things are normal and when they're not. And that's what's occurring right here. We'll look at a better example of this a little bit later, but that's what we're starting to see here is the system is looking at how much data volume is flowing through for a period of time, and then letting us know with this pink triangle that this is an abnormal point, that this is not within the normality that the system is used to. And once again, this does not necessarily mean that this is a horrible, bad action, or maybe it does. It's just the system is letting us know, once again, something's not quite right, and we might want to do something about that or look into it. It's really all for these dashboards. I want to get into the lab, so let's go ahead and do so. So we're going to see many of these panels in the labs. We'll be doing a bunch of them. So let's go ahead and start getting into the labs. Let me share all that information with you right now. And let me get that a lot bigger. And let me put these credentials into the chat as well. If you worked with us yesterday, you probably used credentials very similar to this. Yeah, you probably used the same kind of credentials. If you want to use the same one you used yesterday, that's fine. If you don't, that's fine as well. We're going to go to service.sumologic.com to log in, which hopefully you're familiar with. If you're not, that's fine, but that's where we're going to go to log in. The email address we're going to use is training plus analyst number. So you're going to pick a 3-digit number. Maybe you want to be training plus analyst 245 at sumologic.com, training plus analyst 791. Pick a 3-digit number. And if you're using the same 3-digit number as somebody else, it's fine. For today's exercises, it doesn't really matter. And then the password we're going to use is August 21 exclamation point. So capital AUGUST 21 exclamation point. Go ahead and please log in. If somebody could just let me know when they're logged in successfully, just so I know that we're starting to get in. If you need any help, of course, let us know. That's why we're here. You can also use these credentials after today, so they'll be good for the rest of the, well, about another week or so. And then we can provide you new credentials. Keep in mind, these are, it's a training environment, so don't put anything proprietary, don't put anything you wouldn't want anyone else to see. It does get deleted periodically, so don't put anything that you expect to see a month from now. I'm sure you've used many training environments before. So, all right, good. Looks like a bunch of us are getting logged in. I'll wait just another kind of moment or two. Actually, you know, while I'm waiting, or not waiting, but let me go ahead and put the labs in the chat. This will save all of us a lot of time. So what I'm putting in here, there we go, in the chat. Oh, sorry, let me do that again. There we go. I put that in the chat now. And let me put those credentials in again properly in the chat. I didn't do that earlier. There we go. So the link I put in is a link to the labs. So if you want to go ahead and just open it directly, probably easier. And then we'll go through these together, of course. We might as well start to get logged into those. So at this point, hopefully we're logged into Sumo Logic using those training credentials. And now we've opened up the just the help documentation that has our labs in them. Yeah. So I'm going to keep going. Once again, if you need help or came in late or whatever, just please let us know. I don't want you to fall behind. And also, if you have trouble logging in, you can watch. We will be going over this thoroughly. Also, I saw a question came up. We'll be sending out a recording at the end of today, maybe tomorrow, depending on when we get to it. But it should be tomorrow, your time. All right, so let's start with lab 1 here. So we're going to go through these together. I'm going to do them on my screen. You do them at yours, and we'll talk about them as we go through them. So in this lab, what we're going to do is start with monitoring user activity. Certainly, monitoring user activity is going to be helpful to understand what your users are doing. In this example, we are going to be using AWS CloudTrail data, but that's just as an example. As discussed a few times already, Sumo is multi-cloud, so it supports all different ingestions of data. But for the first few exercises, we do utilize AWS. And so what we're going to want to do here is create a query utilizing the AWS data and looking for user activity. So we're going to create a query that's going to show us the top 10 AWS activities with user information. The reason we're going to do this is many reasons we're doing this lab. Certainly, we want to show how to access that data in Sumo Logic. We also want to discuss parsing, specifically with JSON, which is actually going to be very easy to do. And then we're going to also do a visual chart. Once we create that visual chart, we can then go ahead and turn that chart into a dashboard with some filtering panels. So we're going to be creating a query, turning that into a chart, taking that chart and adding it to a dashboard, repeating that a few times and creating a dashboard that has multiple charts. And then what you can do is you can then export the dashboard out of the system. We'll talk about that in lab 7, and actually import it into your own environment and modify a few things, primarily the source category. We'll talk about this in more detail when we get to lab 7, and use those same dashboards in the real world. So you will have a takeaway today of some dashboards. And so let's go ahead and start to put this all together. What we're going to do first is we're going to go ahead and grab this query here. So I'm going to go ahead and copy this query, and I'm going to go ahead and paste it into Sumo Logic. In Sumo Logic, I'm hoping you've been in here before, but if you haven't, we should do a quick tour. We're going to be primarily doing log searches today. So what we want to do is we want to really just go in and go to log search, or go to the blue button where it has plus new and go to log search. Once we're in the log search, we're just going to go ahead and paste that query in that was in lab 1, step 1. And we can go ahead and run this query as is. Now, what's this query doing? It's doing a few things. The first thing it's doing on the very first line is grabbing the data. So we're specifically saying grab CloudTrail data, specifically that is located in or has the metadata of lab/AWS/CloudTrail. So we've ingested our CloudTrail data, we've provided a tag or a label on it, and now we're saying let's use that tag or label to find that data for the last 15 minutes. So we do have a time period here as well. Once we've done that, we get our data back. Now, these next 3 lines are using parsing. And what they're doing is they're taking the data and looking for portions of the data, specifically fields, and turning those into almost like key value pairs, if you will. What I'm going to do is I'm actually going to, let's see, I'm going to take a step back. I'm going to comment off some of these lines and just grab that CloudTrail line, that first one. When I run that line, what I see here is just my, not just, it's important stuff, but I see my time and my log message. Very simple data appears when you do just a basic search like that. But what I see on the left-hand side of the screen are these hidden fields, as they're called. What this means are these are all fields that have shown up in the log messages, in the log message itself, and the system is identifying them. And it's starting to identify them as key value pairs, essentially fields with values. So for example, we are interested in the field for user identity.username. And what we see on the left-hand side of the screen in this field browser is a field called user identity. And if we scroll in or zoom, well, not zoom in, but dig into that user identity, we see a field called username, with a whole bunch of different values. Now, what we're doing here with the second line is we're saying, go ahead and utilize that field of user identity.username. Here it is in a log message. And when you grab that field, go ahead and call that field actor instead. So I don't want to refer to that field anymore as user identity.username. I want to refer to that field as actor. This next line here is going to take that field of event type that we see right about here, and it's going to rename it to event underscore type. It's pretty much the same thing, but we are adding an underscore. And then finally, what we're doing with this last line is we're taking this field of source IP address, and we're going to call it src underscore IP or source underscore IP. So now we have our CloudTrail data. We have an IP address. We have an event type, and we have an actor or a user. So now what we know is that OnKit did an AWS API call from this IP address at this time. Once again, doesn't mean that he's a malicious hacker, but we are starting to get information about what people or individuals are doing, which is good. Oh, there's a question about why is there this error mark? This is just the, this is Chrome, or actually it's Grammarly, I think, thinking this is a error. So it's not, yeah, it's just a browser artifact, not an actual error in the system. Good question and an annoying feature. So we have our query going. So now what we could do is we could scroll down a little bit further to step 5 or step 4 we just did. Now we're going to add step 5 in here. And step 5 has us adding this line that looks kind of weird, but let's go ahead and add it and I'll explain why we're adding it. So we're going to go back to our interface. We're going to do a shift enter to get a new line. And then we're going to paste that where event type matches event type line. And I'm going to click start. And it's not really going to do anything different because it's pretty much the same thing where 1 equals 1. It's not doing much. But what it does give us the ability to do is utilize a feature that we call parameters. Parameters allow us to turn something and allow it to become a, allow us to add some predefined options as well as alter our query in a different manner. And that was a really poor explanation. So let's go ahead and take a look at what this does. What I'm going to do is I'm going to go to where event type matches event type. And I'm going to highlight this, the second event type. So I'm going to have where event type matches highlighted event type. Once I have that highlighted event type, I'm going to click on this option here that should show up now that says create a parameter. What it does is it now turns this second portion of that query line, the second event underscore type, to a parameter. And so we're going to configure it as the lab describes. It's going to be probably pretty much the way it is defaulted. I'm just going to modify this portion to underscore event type. And then I'm going to go ahead and click save. Now what it does is it now allows me to input a event type. So if I want to say only show me AWS API calls, now I can do that. So what I can now filter on is my event type. Now I could always just add a filter here that says where event type equals AWS API call, but we're going to use this parameter and use this in our dashboard shortly. So this is going to be it's going to be helpful in the long run. Might not seem helpful right now, but it will be. All right. Now what we're going to do here is we're going to create a second filter. The filter we're going to create here is around actor, because what we want to be able to do is search on user or actor. So we're going to go and add another line of where actor matches actor. It's going to put in that parameter field. We can go ahead and say, show us all the actors, show us all the event types by just using stars in there or wildcards. And now it's showing us all event types for all actors. Now to finish up the lab, we have a few more pieces of content to add. And that's going to be these last 3 lines. So what these 3 last lines are going to help us with is aggregating the data and formatting it into something that's more helpful. Because right now, what we have is a log message with a user, an event type, and a source IP address. But if you remember, the goal of this lab was to look at the top 10 users. So what we need to do is take our data and just show top 10 users. And that's what we're doing with the last 3 lines that we just inputted. I'm going to go through each line one by one to show you what it's doing. But the line itself should indicate what it's doing. So let's take a look at it. What I'm doing with this line is I'm saying count by actor, event type, and event name. So what's going to happen when I click start is I'm going to get a new tab called aggregates. And what it's going to do is it's going to take all the actors, all the event types, and all the event names and add them all up. And I should do this for the last 24 hours just to get some more data in there. So I'm going to click start. Now I get that aggregates tab. I get that actor or that user. I get the event type, and I get the count of what they did. Now what I'm going to do is go ahead and actually, I don't know why we use event name in there. That's not really a field that we're carrying across. Yeah, don't really need that one. In hindsight, I should probably remove it from the lab. But let's take a look at the next operator, which is the top 10, because right now we have a whole list of users, actions they did, counts, but we're trying to find the top 10 of those. So what we're going to do is utilize this next line. Top is an operator. The top X, the top what, the top, in this case, the top 10. What do we want to find the top 10 of? We want to find the top 10 actors. Maybe we want to find the top 10 source IP addresses. Well, in this case, actor. And we want to find it by event type and count. So when I click start, the system's going to take that list. It's going to sort it. It's going to keep the top 10 users, and it's going to show by event type those counts. Now what we can do is utilize the transpose feature. This feature is going to take our data and modify it to give us a feel of or look of Excel, where we have rows and columns. So we're going to run this last time.
Sorry to interrupt.
No, go ahead.
But how it find top 10 now? You have given actor by event type and count. So how it found, like we have not given any criteria there, how it found this top 10?
So it's actually doing the top 10 users by it's doing so it's basically taking the lists of and sorting them. So let's go ahead and take a look, step back. So it's basically sorting the list, keeping the top 10, the count, and then dropping these smaller ones. We can specify how we want to do it, if we want to do it by count or not. So, but we can go ahead and leave out the event type, but we want to include that in because we do want to report on that. So it's just taking that list and just truncating it. It's not sorting it automatically though, which we could do. We could have it sort the aggregates there. And then the transposing is going to take that a step further and take the actor and the event type, those fields that we really care about, and then show us the count in the intersection. So now we start to see how many API calls and console sign-ins each user was involved in. All right, any questions about that or additional ones?
I have a quick question. Like, I mean, when we do top 10 actor by event type and count, the event type is a single value, right? Whereas count is something which we are doing an order by, right?
Correct. So
Okay,
when
sorry, go ahead.
yeah, so we can leave, if we leave off the count portion of it, it's grabbing it by event type, and it's grabbing it, I think, in alpha order, the event type portion. So it's looking for an actor and then by the event type. And then when we bring in the count, it's just displaying that value associated with it. So there are other ways to write these queries. So we could go ahead and say, show us only the AWS console sign-ins. We can modify that a little bit.
I think it is actually, though it is bringing top values, but I think it is taking the first 10 results only and showing there.
Yes, I believe so as well. Yeah.
Yeah, because it's just showing, because there are multiple event types, but still it is showing only 2 event types because it's just fetching the 10 results out of the criteria.
Yes. Oh, I see what you guys are saying. Yes, yes, it is. Yes, it is doing that.
It is not by event type for each 10 results. It's actually overall the criteria, only 10 results it's bringing in.
Yes. So it's really more, it's acting almost more like a limit than a top for in this case. I'm not quite sure why though. That's a good question. I'll have to take a look at that.
So like in this top 10 actor line, if I just remove the event type, will the results be still the same, like the top results that I get?
So they should. What I think we have these is flip-flopped. So let me
Yeah, actually, the top 10 is only brings the whatever the criteria by, okay, on that it just brings the 10 results. That's what I can see from the query. I mean, whatever the by criteria, after applying the by criteria, it just brings up the top 10 results of that one.
Yes, and then shows just the event type as a value, not really sorting it or anything.
No, in the previous step, when we did only count, then it showed properly. It was showing only top 10. When we are adding the event type, then the issue is coming because for the same user, based on the event type, it is showing.
Yeah, the result is
number of
getting
count.
the result is getting changed every time. If see for count, just for count, it is giving top 10 count, and when we were giving first event type, this top 10 count was not there.
No, this will not be there. Can you make event type also along with this?
Because in that event type, what are the top 10? It will bring that.
Yeah. So here, if you see first one, Kevin, for API calls, it is 19,000. Again, on the 7th number, you have Kevin for something else, which is the top there. So it is showing for each event call who is top.
I think it's sorting on basis of what
yeah,
we
it's
placed before.
So if we
Yeah,
place
first-
underscore count before of event type, it's sorting on basis of underscore count.
Exactly.
And if you place event underscore count before underscore count, or event underscore type before underscore count, then you'll see that all the AWS API calls are paired up together, and then you'll see AWS console sign-ins. So the sorting is determined by which particular name is
Yeah.
placed before.
I
Correct,
think first it sort with the first key, then it sort with the second key. But as none of the count is matching, that's why it's not sorting with the second key. Yeah, please carry on. I think we got it.
In case for
Okay.
Kevin, you will see that his name appears at first and seventh, but AWS API call is 19,000. That's why it shows up first, and then AWS console sign in as showing up as Kevin for 1953.
So team,
it's
this is
demarcating.
essentially, yeah. So this is essentially we are counting based on all the three. We are looking at actor, event type, as well as the count. And now we are limiting it to the top 10. And when we don't limit it to top 10, we are counting, or we are limiting it by the count and then the event type. That's why it is showing up in these three combinations. If you remove any one combination, then you can see the results for the other two fields.
Yep. Okay, very good. So let's go ahead and continue if that's all right. Good dialogue. So what we want to do next is we do want to create a chart from this information. So we have our transpose table. And now we have the ability to modify this and put this into a different view as a chart. So we can go ahead and select many different charting options. I think in this case, we're directing you to utilize the bar graph. And so now we have a query using parameters, and we have a chart down below. Now what we want to do before we change the save this is we do have the ability to modify some of these fields, some of these values rather, excuse me. So within the chart itself, we can go ahead and do things like change the legend and modify where things are displayed, change the color scheme, things like that. Might not sound super important, but it's helpful. People asked for it. And what we're going to do now,
Kevin, can we define ranges, okay, based on the count, okay? If I want to display the colors, like, if my value is about 10,000, count is about 10,000, I would display red, okay?
Yep.
Like a range definition. Yeah.
Yep, absolutely have that. Actually, this doesn't work very well with this example, but you can go ahead and do that. So you can specify. It works better with this one here, where you can go ahead and colors value range. So you do have that ability to do some of that, not particularly with this chart, this bar chart though. But with using the single value range, you can go ahead and do so. And once we have that graph, however we want it, then we can choose to add that to a dashboard. So when we add to a dashboard, we're going to go ahead and give it a name. Sorry, here we are, we're down here. So we're going to go ahead and add that dashboard, and we're going to call it sock underscore our initials and then the login we're using. So I'm going to use sock underscore JB /123. And I'm going to go ahead and call my dashboard the same name. Actually, for this one, I'm sorry, I should actually call this top 10 user activity. When I click add, I'm going to go ahead and click add panel here. We can ignore this right now. Oh, I already had one created. That's what I was afraid of. Let me create a new one. I'm sorry. Let me add the dashboard. Top 10 user activity. Sock. JB 1, 2, 3, 4. And so now what we have is we have a dashboard with our panel. What we're going to do later is we could start, or soon, but we've already started to do it, but we're starting to utilize filters within our dashboard. So what we're going to be able to do later, or we can do it right now, is we can now start to filter on specific users. If we just want to view Ankit's information, we can go ahead and filter just on a specific user. Let's see. Oh, because Ankit's, that's not the proper spelling. Let me do it with Goza. There we go. So then we can start to filter on specific individuals. All right, so let's go ahead and so at this point we should have our dashboard, we should have our one panel, and we should have our filters as well. And now we're going to go ahead and jump into lab 2. Now lab 2 is going to go over geolocation, and we started to look at this in the I pointed it out earlier, the map. And so we're going to go ahead and show you how to set one up. As you'll see, it's pretty easy to do. And so let's go ahead and go through those steps. This first bunch of steps are going to be very similar to what we did earlier. We're going to be doing geolocation, and we are going to use AWS CloudTrail data again. Once again, just another example of data that we want to use. The same data we used before, but just we're using this as a source. So we're going to go ahead and go to lab 2. I'm going to go to step 2, and I'm going to grab all 5 lines there and bring those into a new log search. So I'm going to go back into Sumo, do a new log search, paste it in. And once again, as discussed, we're pulling the CloudTrail data in the first line, and then the other 4 lines are grabbing those fields within the JSON file and grabbing those and turning those into fields that we want to utilize specific names. So once again, we're using that user identity, that username, we're turning that into actor. We're taking the source IP address, turning it into source_IP, so on and so forth. Now we can go ahead and do these next steps here. Yeah, we should. What we're doing here is doing the parameters again. So these are helping set those up. These both in step 4 and step 5. This is just configuring the parameter. And we're going to do this a lot through each lab because we want to set up those parameters so that we can utilize them as a filter in the dashboard for multiple panels of the dashboards at the same time. And we're going to go ahead and put stars in each one. So that way we're getting all of our data. So we're basically saying show all the data except if the actor or event type is empty. Don't show them. And then we're going to use these last 2 lines to set up those parameters in the same way we did just before. And we'll do so, like I said, many times again. Now we want to start to bring in the geolocation, the whole portion of this query. Now, for this query, we have IP addresses. Each line is going to have an IP address. Now, how do we take that IP address and turn that into a location somewhere in the world? Well, we do so through this last line, this one line of code here. I'm going to grab this line and copy it and paste it in. And I'm going to run it, but I'm also going to talk about it before I run it or as I run it. So I pasted it in. So what is this line doing? What this line is doing is it's utilizing a lookup table, and it's utilizing geolocation data and allowing us to take our IP addresses and look them up and see where in the world they are. So what we're doing here is this line reads easier if you read it from right to left. So what we're doing is we're taking our source IP, that IP address that we have in each log message, and we're comparing it to the IPs that exist within this geolocation lookup table. This geolocation lookup table is data that geographic data. This is not our data. We are not great at geographic information. That's not what we do. This is a company called Newstar. They are experts in doing this. Same way CrowdStrike is experts in threat intelligence data, and we'll look at that shortly. Newstar does a great job of this geolocation, and so we're utilizing their data and letting you utilize it. So we're taking the IPs, looking them up in this database, and from that database, if the IP is found, we are going to retrieve these pieces of geographic information: the latitude, the longitude, the country name, the city, as well as the region. We don't need all that information, but I'm going to retrieve it because I want to show off the lab. Suresh has actually put in the help article for this GeoIP, which is a great article to get more in depth in here. What we now see is for each city, for each IP address, we see a city, we see a country name, and we see a latitude and a longitude. Latitude, longitude, and so on.
I would just like to add a point here.
Sure.
You can use a simplified version of this query with the help article that I have posted. You can simply type GeoIP space source_IP, and it will give you the same output.
Yeah, and thank you for pointing that out. We continuously improve the system, and this is the old way of doing it. And I just haven't updated the lab yet. I apologize for that. I should have, because the new way is.
Josh, you are right. These are two ways of doing things. The latest operator is the GeoIP space IP address. It simplifies things. Nothing else.
Yeah. And so now we have this information, regardless of how we get it. If we do it our method or the one that Suresh pointed you to, we're still going to get the IP, the data, the latitude and longitude. What we're going to do now is we're going to add this last line here, this count line. What this count line is saying, and let me go ahead and put it in, is it saying count by actor, so count by user, count by address, IP address, latitude, longitude, as well as country name and event type. When I click start now, the system is now going to add up all those log messages. And for each log message, it's going to find the actor, the user, the IP address, the latitude, the longitude, so on and so forth, those things that I just described. Now, what we can do here in step 7 is turn this map, or turn this data into a map. By having the latitude and longitude, that's all we need. We can go to the map icon and click on it. And what it's going to do is it's now going to plot those points, those IP addresses on a map. And now we're looking at, over the last 15 minutes, those users that have logged in to CloudTrail. And now, as I described earlier, this is giving me an understanding of where my users are coming from in the world. And if I'm not doing business in South America, or somebody's coming out of China, that might be suspicious. It might not be, it depends on the organization. But this is being revealed to us or shown to us right now. And what we can do now is we can, as we've been doing already, we can now take this panel of data and add it to our dashboard. So we can go to add to dashboard, give this a name, geolocation, and then find our dashboard. Click add. And now we have, add panel, you can just ignore that. Or not ignore, click add panel when you get that. And now we have our dashboard with 2 panels, one with our user activity and now with our one with geolocation. And what we can do, continuing with the filter, is we can go ahead and, if we wanted to, we could filter here. So we could say, you know what, let's just look for Kevin. And now we see under top 10 user activity, we're just going to see what Kevin did. And for the geolocation, we're just going to see where Kevin is located. And now, once again, this may be curious, this may not be. If Kevin's in charge of VPN access, then this makes sense. If Kevin's on vacation, then this is kind of weird. All right, let's see. Anything else in there? Okay, so let's go ahead and keep going here into lab 3. We'll probably take a we'll take a break soon, probably after the next lab. All right, so lab 3 is having us looked at the top 10 number of failed login attempts. So what we want to do here is we want to find out when a user is unsuccessful in logging in. So what we're going to do in this lab is we're going to look at the incoming logs, and we're going to look for login failures, and then we're going to do some aggregation of that data. So the first portion of this lab is going to be pretty repetitive. Again, we're going to look at that AWS data. We're going to grab all those fields. We're going to take those fields and rename them. And so I'm just going to go ahead and do a new log search again, paste that step, those first couple steps in there. I'm going to go ahead and run it just to make sure I'm pasted it incorrectly, which I did, which is good. Now we're going to go back. We're going to go ahead and do the, as we did earlier, these parameters. So we are going to grab those parameters, grab those two lines to create those parameters. And we're going to put stars or wildcards in those fields that the parameters create. And now we're going to go ahead and start to limit the data. So what we want to do here is we want to add these two lines here, where result equals failure and where event type equals AWS console sign-in. The reason we want to add those two lines is because that's what we want to look for. We want to look for where somebody tried to log into AWS, so where the event type was of the console sign-in, and where the result failed. In this case, I don't care where result equals success. I may in the future, but for this case, I just don't. It's not important to me. So once I have those in here, I'm going to run the query again. The query should run. I'm just going to verify it does. And now we can start to do some aggregation. Now, I think we're going to have a similar issue that we just discussed previously with the top 10, but let's go ahead and try it anyhow and see how it works. So I'm going to grab these three lines here in step 8, and I'm going to paste them in. I am going to go ahead and increase my, actually two different things here I need to do. I'm going to turn these lines off. I want to just go through these lines. And before I go through them, I am going to turn this to last 24 hours. I just want to get more data than just last 15 minutes. So now I'm rerunning this just for the last 24 hours. Now, what we want to introduce here is a feature that we call time slice. And you may have saw the, actually, I don't think you saw this yesterday. You may have, either one, doesn't matter. What time slice allows us to do, or allows the system to do, is take data and, kind of as the name implies, slice it into groups of time. So what we're going to do is, rather than looking at the last 24 hours and looking at each log message, we can say, count our data and group it together in groups of 1 hour time buckets. So rather than showing us the last 24 hours, show us data from 8 a.m. to 9 a.m., from 9 a.m. to 10 a.m., from 10 a.m. to 11 a.m., and so on and so forth. And what we're going to do in this next line, if we're then going to say count by those time slices and those actors and those event types and those other things. So it should group us data by 1 hour bucket of when this person is doing those actions. So I'm going to click start. It's going to start to count. And so now what I see is Jay Schmo, for example, between 10 a.m. and 11 a.m., he was unable to log into the console one time. From noon to 1 p.m., Ankit was unable to log in one time. From 2 a.m. to 3 a.m., Ankit was unable to log in one time. So I'm seeing those. Now what we're doing is we're going to use that top operator once again, and as we discussed, I didn't mean to delete that. We're going to go ahead and run this. And what we would see here are those time slices. Yeah, this is not, it's as discussed, it's well, it's showing us by actor, by time slice, the event type with the result and the count. What it's not doing here, and that's what we were kind of discussing earlier, is it should group them. Oh, it is still running, actually. Let me be more patient here. Because I thought I did have a time period where I did have 2 of these.
Joe, sorry to interrupt again.
Sure.
You have created where event type matches event type. Okay, one parameter for event type, and then you have hard coded event type is equal to AWS console sign in. So if you'll pass anything else, it will always give 0.
Yeah, that's a good point. That's a very good point. We should have really done it up here. Excuse me, up here. Yeah. Yeah, and it would be the same action of putting it right there or putting it right there. But that's a very good point. Yeah, it's only going to bring at that point only those AWS console sign-ins. But it should be, let's see. And then we see them down here. So now they are grouping them by the times and then by the other types. All right, let's go back to our lab here. And then finally, what we're going to do again, like we've been doing, is we can then take this set of data and then add it to another dashboard. Excuse me, add it to the existing dashboard. So
even in this case, I think the count should be in the start for the after by, because the result seems to be a bit different. Like,
oh no, I agree. Count. Yeah, it should be. Let's see what that does. That's what I was. Yeah, this is what I was expecting. Yeah, this is really what it should be. I'll make a note to change that. Yeah, good comment or observation there. So this is really showing us what we want to get. Those 1 hour periods that have the most failed logins. And so now we see those, and then 2 with 3s, and then the other ones with 2s. Cool, good observation. All right, let's see. Let's go back to our lab. Then we added the panel to the dashboard. We're just starting to do that, so let's do that. Failed logins, and what we're going to call this was the same one. See, there it is. Did not like my dashboard name. Is it not liking? The dashboard. There we go. Sorry about that. And then add panel. And now we have those filters. But as described, if we keep the where statement in this search 3, this event type doesn't really do much other than show us only those failed logins over here, which is okay because that's really all we're interested in. And now we have three panels. All right, let's go ahead and let's do one more and then we'll take a break. Lab 4 is, well, they're all good labs, but this one's more aggregation actually. You know what? Let's go through it. It's going to be very, very similar to the other one. So let's go through this, not quickly, but what we want to do here is we want to look at brute force attacks, and brute force attacks are bad. What we want to do is look at when they're occurring. And when we refer to brute force attacks, what we're talking about is a large number of attempted logins. And the way we're going to kind of detect these brute force attempts is by looking at the CloudTrail data for a high number of failed login attempts within a period of time. So we're going to find a period of time where somebody failed to log in a bunch, and our assumption, or not necessarily assumption, our hypothesis might be that because somebody could not log in many times, they were trying to brute force. Now, it could also mean they just forgot their password and they were trying many different passwords, but it does show that somebody was actively trying to log in a lot. The reasons we don't necessarily know. So to do this query, once again, very similar. Grabbing that first chunk of data, that source category, those fields, doing a new log search and just pasting that in and running it just to make sure we get data. Now we're going to go ahead and do those parameters. So as we've been doing, grabbing those where event types, where actor matches, pasting those in, adding stars or wildcards just to fulfill the query. And now what we're going to do here is we're going to use some aggregation, but we're going to use some conditional statements. So I'm going to grab the content in lab 7. Excuse me, step 7. I keep doing that. In step 7, I'm going to paste it in, but I'm going to go through it line by line. And before I do that, I'm also going to increase my time range to just get more data. So right now I'm looking at the last 24 hours. I see a user and I see whether they logged in successfully or not. That's what this result column is showing. And what I'm going to do now is I'm going to take my time slice operator. So I'm going to say, take all my data and slice it into groups of time, specifically 1 hour buckets. And by doing these 1 hour buckets, I'm going to start to use these of saying, how many times did somebody log in from during a 1 hour period? If it was a lot or a little, that might indicate that as a brute force attempt or not. Now I can run start here, but nothing's going to occur, even though I put this operator of time slice of 1 hour until I use it later on, which I'll use it in the last line here. It's not really doing anything. So yeah, it's really just not doing anything. But now what we want to do is we want to start to use our if conditionals, excuse me, and start to use these in a tally system format, which is pretty neat. And I'm going to use the first line here. The first line says if result equals success, 1, 0 as success count. Now, what does that mean? What's referring to is the result field and the value of that field. What the system is going to do is it's going to create a new column or a new field actually called success count. And based on if the result is a success or not, it's going to put either a 1 or a 0 in that column. Using binary, using true, false, 1 will be true, 0 will be false. So when I click start, I'm going to have a new column called success count. I'm either going to have a 1 or a 0 in that as a value there. If I have a result of success, I'm going to have a 1. If I have a result of failure, I don't really want to spend too much time looking for 1 necessarily. No, I don't want to look for 1. Actually, here's an easy way to look for 1. I thought that was going to be faster. If I have a result equals to fail, then I would have a 0. Now I'm going to do basically the same thing. Let me get all my data back. Okay, I'm going to do basically the same thing on this next line, but I'm going to create a new column called failure count. I'm still going to look at that result, but now I'm looking to see if it was a failure. If it was a failure, I want to tally a 1 in the failure count. If it was not a failure, I want to tally a 0 in the failure count. So now for each log message, I'm going to have a failure count as well as a success count. And for each message, I'm either going to have a 1 in the success count column or a 0 in the success column and a 1 in the failure or a 0. So it's going to be a 1 or a 0, either one. So now I have these columns of failure count and success count, these tallies that I'm starting to do. What can I do with these things? Well, what I can do here is I can start to add them up. What I can do is say, take the sum of the success count and add them up. Take the failure counts and add them up. And do this by time slice, by time period, by actor, as well as by event type. When I click start, since I'm doing sum, I'm doing math, I should have my aggregates. And what I now see is for each time period, I see how many successes and how many failures there were. Here, for example, Suraj logged in successfully 13 times. Good. Good job. Yay. Here I see Suraj logged in 22 times, but did not log in successfully 1 time. Now, does this mean that he was maliciously hacking and using brute force attempt? No, probably doesn't. It probably just means he had a typo with one time, but we're starting to get that insight. Now, what we want to do here, to take it a step further, is have the system start to detect a failure percentage. I had a success, I had fails. How do I know if this is good or bad? Well, what I want to do is I want to turn this into a percentage. And that's what step 8 is going to help me with. I'm going to say, show me where the failures are greater than 0. So I want to see where there are failures because we're looking for failed attempts. That's going to be indicative of a brute force attempt possibly. And then if I find those, take the failures and divide them by the success and multiply it by 100, which is going to give me a failure percentage. So when I click start, I'm only going to have results that have a failure. And now I'm starting to get a failure percent. And now I can sort this failure percent. In this case, somebody logged in 14 times and 2 of them were failures, giving us a 16% failure rate. Compared to here, where somebody tried to log in 52 times and 50 of them were successful. Now, once again, it doesn't necessarily mean that this is better than that. There may be a rational reason for what occurred here, but this is a little suspicious. And now the system is letting us know that. And then once again, we can go ahead and take this panel of data, add it to our dashboard. And now we have a new panel. Now, something else we could do here, let me see, we don't really cover. So something we could do here, which I guess is not part of the discussion, but is we could also turn this into an alert. So we could have the system alert us when the failure rate percentage is greater than 25. Because that might mean, you know, if somebody's can't log in, if someone's getting a failure rate of 25%, that might be more indicative of something malicious. Or 80%, that might really mean trying to log in and just guessing at passwords and failing. So we could create an alert here. We just don't go into it, but we do have that ability. And so now we have our new dashboard with an additional panel. Oh, not that one. Here's the other one. All right, so let's go ahead and let's take a little break right now. It's let's see, it's I don't know what time it is, local time, doesn't really matter. But let's do a we could do a 10. What's that?
11:21.
Okay, yeah, let's do a 10-minute break. We're good on time.
Mm-hmm.
So I'll set the timer going here. I'm going to just put myself on mute and probably grab a beverage or something, but feel free if you have questions, put them in the chat, and then we'll continue. We'll have a few more labs and then we'll take the exam and take a break for lunch and then we'll come back again. So yeah, hope that works out for everybody and talk to you all in a few minutes. Thank you all. And I'll pause the recording as well. All right. All right, welcome back, everybody. We'll go ahead and get started. I see there's a couple questions on that chat, but we'll have Suresh will come and answer those in just a moment. So let's go ahead and keep going here. So let's see, where did we stop? We stopped at lab 4. So lab 5 would probably be a good place to pick up. So in lab 5, what we're going to do is we're going to talk about a feature. It's utilizing GeoLookup. This lab is involved. Conceptually, what we want to do is show you what we're trying to point out here. And what we're addressing here is that example I showed earlier of where a user had logged in from 2 different places around the world during a period of time, and it was suspicious. And so what I wanted to show here is how this is calculated. A lot of this gets very in the weeds as far as really gets very specific with some of the conversion and some of the filtering. So there are some steps in here that we will kind of not rush through, but kind of jump through. But I did want to show this anyhow, because I do think it's a good use of the operator and just a different way of looking at things. So what we're going to do here is look for a land speed violation. So that's when a user logs in from one location, logs in from another location within too short of a time to be practical. So we want the system to help determine if it's physically possible for someone to travel at a realistic speed from one part of the world to the other. So how do we have the system look at two different points in the world, figure how far apart they are, how long it would take to get there, and if that's realistic or not? And that's what this query is discussing. So here is the query flow chart that's going to go through the steps of what we're doing. These middle steps are where it gets kind of, like I said, kind of in the weeds. But essentially what we're going to do is we're going to select source category like we've been doing, so CloudTrail or something like that. We're going to parse out the user and IP address information. We're going to filter out any null IP addresses. So if there's any addresses that are not IP addresses or are blank, we'll filter those out. We're going to create the start of when a user logs in. So we're going to look for when a user logs in and examine the number of times each user has logged in from that IP address. We're going to filter out single logins to avoid null messages. We only want to look for those logins that are successful during a group of time. If somebody just logged in one time, that's not what we're looking for. We're looking for multiple logins from the same IP address as well. We're going to do so by converting some of those IP addresses to a decimal format, and then we're going to actually turn it back. And that's where it gets a little weird, but that's why we're doing it. We're then going to take that IP address and look it up and do the geolocation like we did earlier. Then we're going to use what's called a Haversine formula to help us, or help the system, calculate the distance between two locations in the world. We're then going to specify the speed a user would need, or we're going to be told rather, excuse me, a speed that a user would need to travel in order for that to be possible. And then we're going to go ahead and specify an impossible speed, the speed that somebody cannot travel faster than. And so that would make that situation impossible and then present it to us. And once again, does it mean someone's a malicious hacker flying on a super fast jet across the world? No, but it might. And that's what we're being told here. So for this query, I'm going to go ahead and like we've been doing, I'm going to grab step 2. And I'm going to grab that query and paste it in. This query has some commented off sections, which are just describing those steps. So while the query looks, well, it is more advanced, there are just some additional comments in there. But basically what we're doing is, as we've been doing before, grabbing our source of data and then starting to grab some of our data from that message and filtering it out. So in this case, taking a user identity and a source IP address and calling those fields user and IP. Running those just to make sure they work, which is good because typos are annoying. And then we continue. Now what we're going to do here in step 3, this is where it gets a little, like I was saying earlier, kind of in the weeds. But what we're basically doing is looking for the first time each user logged in and what IP address they used, and then sorting the data by the user and their login time. I'm going to drop that in, paste it in. Oh, I am using the actor again, so we're going to use that parameter. So I'm going to put the wildcard in there. Let it run just to make sure it's running properly. And what I'm now starting to see is a user, the IP address they logged in from, and the time. And as it says, your results should look kind of like that. Now what we're going to do is we're going to do some filtering for non-existent IPs. So what we're doing here, and this is another spot where both this step and the next step is where it does get, like I said earlier, kind of in the weeds. But what I'm doing here is then filtering users that only have a login, a single login. So I'm saying here with these lines, look for the users. If they've only logged in one time, don't show it to me. If they have a null message, don't show it to me. But what I'm now starting to see is Siraj logged in from this IP. And he also logged in at these other times as well. So these previous logins. So here's one login, here's another, and now we're going to start to get deeper and start to look at those physical locations, but that's where the data is leading us to. This next line is taking the IP address that we put in decimal form and turning it back into an IP address. But so what we're starting to get is Suraj logged in from this IP, Andy logged in from this previous IP at this time and at that time. And as we continue with this query, we'll start to figure out, is that possible or not? Now we're going to use the geo lookup because now we have an IP address for our users. So what we're going to do here is we're going to go ahead and say, look up the latitude from this IP address. Then look up the latitude for the previous IP address. So what I should have now is for my IP addresses, I should have a country and a latitude and longitude. And then I should have a country name and a latitude and longitude for the previous IP. So now I'm starting to see Suraj logged in from Iceland and Venezuela. Going to keep following along here.
I have a quick question.
Yeah, sure.
So what is the rationale for converting IP to decimal format? Like,
So it's
I didn't understand.
no, yeah, and that's where it really gets into the weeds here. Is so what we're doing is we're using this IP4 and the 2 number and the backshift operator, and so it's allowing us to look for those IPs that exist by the user. So we're using the backshift operator, which is not something we use too frequently, but what it's allowing us to do is compare values in a point of time. And so we're starting to say, look at this point, look at this previous point. Why we're specifically doing decimals. Let's see.
While I don't know the answer for this, maybe it is because we want to compare 2 points. Only if you said decimal, we may be able to compare, not the IP address.
Yeah, there was just an issue with the lab not working when we had made it a long time ago. This might not even be needed anymore, to be honest. Yeah, and that's where it does get it. I think you could do it without this step. You'll also find, and this, Suresh kind of mentioned this earlier, there's going to be many ways to do things in Sumo, even the same function. So you could write it this way, you could write it another way, not necessarily bad or good. Yeah, so I don't know specifically why. Let's see. Yeah, we're turning them into octets. I'm not quite sure why we're doing that. But once we have that done, what we're going to do.
Backshift operator field value must be numeric. So IP is not a numeric because IP contains dots, correct? So backshift operator must takes a numeric value. So that's why we are converting IP into the numeric value and then go using the backshift of it.
Thank you. And that's what I thought, but the confirmation is helpful. Good. Yes, I thought that might be the case. Yeah. So now we have our latitudes and longitudes. We have our locations. The trick here, though, is what we want to do is we want to look for the distance between the 2 points. Now, how do you find distance between 2 points on a globe? It's not that easy. What we're doing here is we're using what's called a Haversine formula. This Haversine formula, or this function, takes, as it says right here, 2 different latitudes and longitudes, takes into account the spherical world and starts to calculate that distance. So when we take this line here in step 7, we're saying use the Haversine on the latitude and longitudes of 1 and 2 and show us the distance in kilometers between those 2. So the system is then looking at a globe, essentially, looking at spherical, finding where one point is, where the other point is, and now starting to give us a distance in kilometers between those 2 points. So between Australia and China is 7,000 kilometers, and Mexico and Australia is 14,000, so on and so forth. Now, that's good to know, but we also want to go ahead and do this next portion that's in step 8. This portion in step 8 is having us take the time change between the logins and convert them into hours and divide by the distance we just calculated. So the reason we're doing this is we can now start to see how fast somebody would have had to travel in order for somebody to get, in order for this to occur. So what we're seeing here, let me clean up the screen a little bit, is the fact that somebody here went from the United States and Brazil, and in order to do so, they would have had to travel 10 billion kilometers per hour. Now that, of course, not realistic. And so that starts to let us know that something might not be quite right. Now, before we finish this, though, we want the system to tell us when those things are suspicious. So what we're going to do with this line in step 9, excuse me, is we're going to go ahead and say, only show us where that velocity is greater than 500 kilometers an hour. Nobody can travel more than 500 kilometers per hour. So if it's under 500 kilometers per hour, that's certainly possible. Somebody could log in from India, drive to another part of India, log in during a period of time. It would be 2 different locations, but they can do that. And so what we're saying is the 500 kilometers or more is just not possible. And so we're saying here 500 is that suspicious speed where the apparent velocity kph is greater than the suspicious speed. We could also just say where apparent velocity is greater than 500 as well, same difference. Now it's only going to show us those suspicious speeds and those that are above the suspicious speeds. Now we're going to go ahead and add one more portion here to this query. This portion is all about formatting and cleaning the data up. And so let's see how this cleans the data up. So what it's doing is it's showing us now these fields of country names. So now we're seeing here's the user, here's the IP addresses he logged in from, here are the countries he logged in from, here's the distance, and here's the speed he would have had to travel in order for that to be possible. Is that possible? No. And so that's suspicious. Does it mean Kevin's a hacker? No, but it doesn't mean he was trying to log in from Brazil and China during a time period that's too short for him to actually fly from those 2 places. And so that's what it's showing us. And now we could go ahead and, like we've been doing previously, we can take this, add it to our dashboard. And now we're starting to get those suspicious times, suspicious logins. All right, a couple more labs. We add the panel, and then once again, we now see all those. And as we've been showing, we can also filter. So if we do, once again, want to filter just on Kevin, we now see Kevin's logins. We see Kevin's suspicious logins, those failed logins he had, etc. All right, let's see, that was lab 5. So next is lab 6. Lab 6 is having us investigate, as it says, using search parameters. This is something we've already started to look at as far as some of the parameters, but what we do want to show here is a lookup table. Yeah, so let's just go through this. It's pretty clear, pretty easy, pretty helpful as well. So what we're going to do is we're going to add a lookup table. We've alluded to lookup tables today. Alluded to them twice, used them once. So we used the lookup table earlier of the geo lookup, geolocation. That's a lookup table. What we're going to do now is we're going to create a lookup table. The table we're going to create is going to be a list of values that we want to use in our filters. So let's go ahead and add a lookup table. I'm going to go ahead and grab the whole query, but like I've been doing, I'm going to go ahead and comment it and start to just talk through it. So I'm going to do a log search, new log search rather, excuse me. And then I'm going to comment off each one of these lines and just go through it line by line. So the first line, I'm looking for that CloudTrail data again, like we've been doing many times before. The second line, I'm going to go ahead and, like we've been doing earlier, I'm going to go ahead and take that field and turn it into a field called actor. So use that user identity and call it actor. So I now have a bunch of users. So I have a list of users that have logged in from CloudTrail over the past whatever period of time. Now what I'm going to do is count by actor. So I have my actors, my users, and now I'm just going to count by the users, because I want to see how many users I have, how many unique users I have, and what those names are of those users. And I see them. So there's a user called Ankit, there's a user called Kevin, etc. Now what I'm going to do is I'm going to remove the count field, because I want to keep a list of these users or these actors. The count isn't relevant. I don't care if Bob or Kevin logged in 1 time or 1,000 times or 3,000 times. Bob did log in, and so he is a value. So I'm going to do this fields minus underscore count. And when I run this, it's going to remove the values in the count column. And so now I just have fields of actors, or just my field of actor with my actors, excuse me. Now what I'm going to do is save this list. I want to save this list of users, these actors. And so I'm going to save it using the naming methodology that's provided here. So I'm going to do JB1234. I'm going to copy this just so I remember it. And now I'm going to click save, or start, excuse me, I'm going to click start. When I click start, what it's going to do is it's now going to save these actors, this list of 10 users, to a table, to a lookup table that's located at shared /JB1234 underscore AWS actor, etc. I'll click start. It's going to mention or tell me that it's saving the file query. I'm going to just click run. And now it's going to return the same thing that it just showed me. What I want to do now here, though, is I want to look up this list. I want to cat it to see if it, I mean, it should be there, but I want to verify. So what I'm going to do is I'm going to go to log search. I'm going to do cat space, and I'm going to paste in that location that I just referred to. When I click start, I should get a list of 10 users. And I did. This table is now saved. I can reference this table anywhere. Other people can use this table as well. But what I wanted to do here is I want to now take this lookup table, and I want to connect it with the parameters. So rather than us going to the actor in the parameters and typing in a name and maybe guessing at the name, we are going to have a list that's pulled from CloudTrail. So we're going to follow these steps here. So we're going to go ahead and we're going to go to, well, as it says, we're going to go ahead into our dashboard. And we're going to go ahead and open one of the searches. Doesn't really matter which search. Once we open up the search, we're going to go to the parameter window, and we're going to go to the actor, and we're going to click on the 3 dots, and we're going to click manage parameter settings. Now what we need to do is point us to, or point the system to, that lookup table. So I'm going to go ahead and pretty much fill in the blanks here. But I'm going to go down to the very bottom where it says choose how you want to build a list of autocomplete values. So I'm going to go to set values for parameter, choose how you want to build a list of autocomplete values for your users, and I'm going to choose lookup. Then I'm going to specify the lookup location, so that's shared location. With that leading slash. And then in the field, I'm going to pull that field for values. That field is actor. And then I'm going to click save. Now, once it's done, if I go to my actor field, I should now have the pull down of those 10 users. The question was, can lookup tables be live where the values are changed as the data comes in? Yes, so they can be. Lookup tables can also be external sources of data. You can have a external CSV of data that you utilize as a lookup table. Yeah, lookup tables are quite versatile. Yeah, now we've created one. Cool. Any other questions about that? Yeah, I'll keep going here. We got 2 more labs. This next lab, well, not to diminish this lab, I guess they're all important labs, but this lab is the exporting of this content. So what we want to show you, I I'll go through these steps. I don't want to not go through them, but what they allow us to do is take our dashboard that we created and export it out. So to do so, we would go to, I'm not going to export it. I'll show you. I'll just walk through these steps. If you'd like to do so, you can. So we're going to go to the black bar and we're going to look in the personal folder for our dashboard that we created. So I go to my personal folder and I look for my SOC JB1234. I can then choose to export this out. Now, what this data can be exported out as is a JSON. So what I'm very simply going to do is just download the JSON. I'm going to take the JSON and move it into some sort of text editor. And what I'm going to do in the text editor is very simply just change the source category. So instead, if you, and this is presupposing you are using AWS data. So if you are, you could change this to whatever you're using in your production environment, specify that source category, and then import the new JSON with that source category defined, and the dashboard should run properly. Because the query should be the same, it's just that source, the formatting of it should be the same. It's going to be a JSON, it's going to have that actor name and all that other kind of stuff in there. But this provides a very easy way for you to do so. The other advantage, and just kind of pointing it out here, is these dashboards are in JSON. And so you can use JSON to modify them. So if you're more comfortable with taking this data and putting it in JSON and modifying things like as it says here, the different sizes, font colors, all that kind of stuff, it can be done in JSON. So some people are more comfortable with that, and if so, you're welcome to do so, to use that. Okay, so that's really it for lab 7. Finally, I want to get to lab 8. Lab 8, in hindsight, I probably should have done earlier because it's an important lab and I don't want to rush through it. But we'll go at an appropriate pace through it. But I do want to talk about this. This is a big distinction of Sumo Logic, is the ability to utilize this data. And this data is quite expensive, and we allow you to use it for free. So we want you to take advantage of it. The data we're talking about is CrowdStrike data. And what we're doing in this lab 8 is we're using, as it says, threat intelligence to avoid costly data breaches. We want to use CrowdStrike data to start to look at our data and let us know, are these IPs good or bad? We're going to get a little more involved in that, but that's kind of the gist of it. So let's start to go through this. Now I'm going to, I'll go through the first couple of steps here. What we're doing here is, I believe we do have a scheduled view running. So what we can do is we can just go ahead and we should be able to do these steps together. Let's see. We should be able to go to manage data. So on the far left in the black bar, go to manage data. Once you're in manage data, we're going to go to logs. And then we're going to go to scheduled views. The scheduled view we're looking for is called IP_threats. Oh, here it is. Good. So what we want to do is we want to click on this view and we want to grab the query that's in there. And that's really all we're doing here, is we're just really stealing this query. And I'll paste the query into the chat. It's a long query, but if you want to just grab it from there, that's fine. So I'm going to grab that query, do a new log search, paste it in. I'm going to run it. It's doing a lot of stuff, but I'm going to talk about what it's doing. So let's go through what did it just spit out? Because it spit out a bunch of great stuff, but like I said, let's talk about it. So let's take the query and let me go, let me just talk through it. So here in the very first part of the line, we're saying grab all of our data. Don't just grab CloudTrail data. Don't just grab O365 data. Look at all of our data. From all of our data, what I want the system to do is look for an IP address. In this case, I'm using regex, excuse me, to locate that IP address. So I'm saying to the system, go to every log message in the system. Look for IP address. Look for number.number.number.number. If you find one, call that an IP address and retrieve it. Don't do it if the IP address is equal to 0.0.0. Don't do it is equal to 127.0.0.1, but do it for all other IP addresses. Once you've retrieved those IP addresses, I want the system, or I'm telling the system to do this lookup line. This lookup line is very similar to the geo lookup line that we saw earlier, except it's for threat intelligence. Once again, reading it from right to left is the preferred method. And what we're doing here is we're saying, take the IP address that you find, 1.2.3.4 or whatever IP address, and compare it to the threats that exist within the CrowdStrike database. From that database, don't grab country, region, location, grab stuff that's related to threats. Grab type, actor, raw, threat level. And for the threat level, what I want to do here is I want to call that malicious confidence. So I'm renaming that. Then a bunch of other stuff is happening. But what we are left with here is the fact that the system has found this IP address, and CrowdStrike has deemed this IP address to have a high malicious confidence. This IP address is specifically associated with the O365 data, which might be relevant, but this is high. CrowdStrike is saying this, and a high IP address is something that has shown up in their systems and is suspicious. If it had said a low malicious confidence like this, then we might not be concerned as much. But high malicious confidence, the system's letting us know, hey, this IP is known for bad stuff. Once again, does not necessarily mean that it's actively doing something bad in your environment, but it's been associated with bad stuff in the past. It's also showing us the actor, so what it's associated with, and which may be helpful in determining its relationship to what's going on. But now that we know that this IP is high, we need to decide what to do with it. So what do we do with it? Well, we might blacklist it, we might whitelist it, we might follow it, we might, whatever we might do with it. But now we're starting to get that information. And so that's where this lab becomes really helpful, is starting to take that data and just locate it. Now I want to keep going here. I will keep going here. There may be questions, but I do want to just get through this next portion here. This next portion is outlier, and I described it earlier. I didn't give it a great description, but I want to play with it, or not play with it. I want to show it because it's an important feature in Sumo. It's a good way to kind of wrap things up as well today, or at least this first portion of today. Let me grab the query and let me go ahead and talk about it. And I'm just putting some spaces just to visually make it easier to read. What I'm doing here is with these fields, I'm saying utilize these fields. So I'm going to go ahead and click start. And so I'm removing a whole bunch of these fields. And what I'm being left with is, so here's everything I removed. What I'm basically being left with is, during a time period, how many, or how many, not how many, but yeah, I guess how many threats did CrowdStrike deem or see? So we're removing a bunch of fields. And so now what we're left with is from 11:22 to 11:23, these are going to be 1 minute time periods. Actually, yeah, they are 1 minute time slices. From 11:22 to 11:23, there was one malicious action found, or one IP that was malicious. From 11:27 to 11:28, there were two. There were also, let's wait, actually, let me see what's going on here, because these two times are the same. Oh, I didn't need all these extra lines. I have too many lines. Let me see, I should be able to just get rid of these, I think. No, we don't have a count. Oh, okay. So what it's showing, I'm sorry, let me describe it. It is displaying properly. So at this point, what we have is, for each minute in time, we have a unique count of where a bad IP address showed up. So it is possible during one time period that it showed up in O365 as well as guard duty data. what we're doing here with the outlier portion is we're taking those counts it's not displaying, let me see. No, that's not what I want. Let me see. Let me see. We were doing pretty well right up until the end. Let me put that, get rid of those fields. All right, let's do this. All right, let's do count by time slice. All right, so what we're being told now, so here's, sorry, so I apologize for that, but what we're now being told is for this period of time, this 1 minute period, because we're doing time slices of 1 minute, we had from 1121 to 1122, we had 917 observations of IPs that might be malicious from CrowdStrike. From 1129 to 1130, we had 969. From 1124 to 1125, we had 1,000. So we have different values. Now, if I was to ask you during a 1 minute time period, if we have 917 counts of malicious, potential malicious activity, is that a lot or a little? Well, it's hard to say. I mean, if you're looking at it at a scale right here, it's probably kind of in the middle. This is high, this is kind of low, so 917 is kind of in the middle. What we want the system to do is help us out with that calculation. And this is where outlier comes in. What outlier is going to do is take the counts, so take those values, look at previous values, and start to determine what is normal and what is not. So for example, at 1121, there were 917 notices of malicious IPs or observations of IPs. The system was expecting between 700 and 1,000. 917 is within that range, and so that's considered acceptable or normal. At 1122, the system is expecting between 778 and 1,032 observations of IPs. It found 1,100, which is more than 1,032. And this count indicator or count violation gets flagged. What we can do here is we can take this data and turn it into a line chart. And by putting in a line chart, now we get the visual confirmation of what's occurring. We see our dark blue line here representing each minute in time, the amount of IPs that were considered bad or malicious, questionable, I guess is probably the better adjective. We see this light blue cloud representing the upper and lower limits of what's considered acceptable by the system using a bunch of values for math calculations. And then we see this pink triangle representing this outlier, this unique period in time where during this 1 minute period, the system was showing more malicious IPs than were expected. I'm going to go ahead and turn this to last 3 hours just to get some more data in there. And now what we see is over the past 3 hours, oh, it's still loading, just a little, there we go. Over the past 3 hours, there have been only 2 times where we had more malicious, or the system had more malicious IPs than were expected based on what had previously reported. And so these might be times that this might be something we want to set up an alert for to let us know, hey, we're getting more of these IPs than we're expected. This might be a sign of an attack. It might not be, but it certainly could be. It's an indication of something taking place. And so this outlier allows you to start to set these values and start to configure these values, excuse me, and define how you want to adjust this range, this view of the outlier, this calculation. Because I can change this threshold from a 3 to a 2, and I'm going to go from having 2 bad points over the last 3 hours to probably having about 15 or 10. And it's going to take a few moments. I'm doing 1 minute over 3 hours. So there we go. So what I'm seeing is, oh, it's still going. There we go. So what I'm seeing now is over the last 3 hours, instead of having 2 bad points, since I've changed the value of my math or the calculations in my math, rather, excuse me, we now see that there were about 10 bad points. And then once again, I could turn these into alerts or monitors and start to get notified when these happen, and then maybe check for the latest antivirus or whatever we kind of do to work around that. All right, so let me go back to the labs. So that should complete this lab. Yep, it does. Okay. Any questions? I know you guys have been asking questions over the chat, which is great. But any questions related to what we've been going over?
Is there
Okay.
an app?
Okay.
Is there an app which can achieve all of this which we do? Because the
There-
queries were very huge. So
Josh, we have lost the audio. We can't hear you.
Oh, I'm sorry. I clicked my mute button. Thank you for pointing that out. So what I was trying to show, or I was talking about, was the ability to use the app. So what I've done is I've set up the app. And so, yes, you can absolutely utilize the app. So here I have my app. Here, I'm kind of crossing my fingers. I hope this works properly. I mean, it should, of course. Yep, and now I'm starting to see. So absolutely using the apps is always suggested. And thank you for mentioning it. I should have brought it up myself. So we always encourage you, anytime you bring new data into Sumo Logic, see if there's an app for what you're interested in, because it's going to provide a lot of those things that we just created out of the box. And yeah, that's a group. And there's searches. Let me wind this up here. So here we can see login activity, for example. So here we have much of what we had just gone over already created for us. Keep in mind, well, no, it should populate eventually. So yeah, using the apps is good. There we go. This is the one I wanted to show. So we have very similar data.
so do we need to add apps based on the source, or can it be added for all the sources together?
So it depends a little bit on what you're interested in doing. So typically it's going to be by source, but if you're doing security, for example, it would depend. So if you wanted to look at all your CloudTrail data together, you could. If you want to separate these out, you could as well. Let's see, which else would be a good one? Yeah, all these are pretty specific to the source of data that they come with. And these are helpful. Well, these are really more internal Sumo apps for internal audit abilities. But so yeah, based on the category or the type, there should be apps that correspond to it.
So once we install this apps, we can still customize those thresholds and everything within those dashboards.
Absolutely, great question. So yeah, the apps are just as we've seen today. Yeah, the apps are just a combination. We haven't actually seen that, but the apps are just combinations of dashboards and queries that have already been created. So absolutely. So here's an app. I have a dashboard. I can now go into this dashboard or this panel. Excuse me.
Josh, I have a question.
Edit it and save it as well. Yeah.
Yeah, Josh.
Sure.
How do you do the same for EC2?
How do you do the same for EC2? So
I didn't see an app for EC2. That's why I asked.
No, there wouldn't be an app for EC2. It would be the AWS. Suresh, do you know offhand?
Okay, so Nachiket, what do you want to see as part of your EC2?
I want the same panels for EC2 like I have for the other services like ECS, ELB, same kind of panels.
I
The
understand.
metrics collection for EC2.
I
Like
understood.
when did I start the instance? How many instances are started? How many are running?
Yeah.
How many like that?
Yeah, so that will not come from EC2 as such. We have a solution called AWS Observability, or we can actually build in those sort of views for you using a different view. If you want to bring in data from your EC2, these can be like logs or metrics that you want to bring in. So we have something called as an installed collector. You can install the collector on your EC2 instance, which will collect the respective logs and metrics and send it to Sumo. You can build dashboards, etc., using that information which you send into. Like how we did now, right? Where you got in the CloudTrail logs and then build dashboard. Similar to that, you can bring in logs from your EC2 and then build it. These logs can be your application logs or something like that. But if you're looking at how many instances that you are running, how your auto scaling is running, etc., we need to look at different data set to understand how many instances are running, etc. That you cannot from your EC2 instance data. Is this clear?
Okay. Yeah. Okay.
Prasanna, I saw your question on the Q&A. You asked, can I have this URL for sample log parse? Can you explain me what do you mean by that? You can unmute yourself and talk, Prasanna.
Prasanna, can you hear us? Okay. Even I
Maybe
didn't.
microphone is muted. We can answer this question directly. Yeah. Yeah, he has replied saying that there are some audio issues at my end. I will chat with him and then take it forward. So, folks, if you have any question, please feel free to raise it on the Q&A button, and then we will keep answering it here. Josh, over to you. You can continue with the presentation.
Yeah, thank you, Suresh. And yeah, more questions are fine. But let's continue. And so what we want to do now is we want to take the exam that corresponds to this course. So we've completed the content for today, which was going through the lab. So, but now we want to go ahead and take an exam. So you probably may have taken an exam with us before. Actually, I don't know. I hope you have, hopefully yesterday. If not, if this is your first time, that's great. We do want to make sure that we take this exam as ourselves, not the training account. So we will want to log into Sumo using, everybody should have either either personal or corporate or a professional Sumo account. I assume everybody does. Hope everybody does. So we want you to log in with those set of credentials. And then we want to take the exam. So once we log into Sumo using our formal credentials, we're going to go to certification and we're going to go to get certified. And I'll go through these steps a few times. So feel free to start to log in. Like I said, I'll reference these a few times. Once we've logged into Sumo Logic, into the certification portal, we're going to go into the, where are we going today? We're going into security at the bottom. And under security, we should have a cloud security monitoring and analytics exam. And so we're going to select that exam. And then if you've taken an exam before, you're familiar with these steps. If not, I'll still go through them. What we're going to do is we're just very simply going to register. We're going to click before you start and read just this stuff. And I'll go through this stuff in a moment. And then we can go ahead and take the exam. The exam is going to consist of 20 to 30 multiple choice questions, 22. You'll have an hour to take it. I don't think you'll need that much time, but as much time as you need is allocated to you. It is open book. So like our other exams and other certifications, they are open book. You have resources in the real world. And so I think you'd be able to utilize those resources, here as well. So feel free to go ahead and use those, the documentation, the help, the labs. Those will be quite helpful in the exam process. Once you take the exam, so if you've taken the exam before, you're going to start it. You're going to answer the questions. What you do want to do, though, is when you click next, it's going to give you your score. Hopefully, you're going to do better than I did. But you do need to click submit once you take the exam. If you don't click submit, it's not going to save your score, which is unfortunate. But that's the way it works. So it's critical that you click submit once you finish the exam. So we'll go ahead and start the exam. We'll give you some time. I think we're also going to take a little lunch break in there as well. And so I think we're going to start back up in about 70 minutes, if that's correct. Poonam or Suresh, do I have my times right?
Yeah, it is 12:19 now, India time.
Okay, and so we have, what time do we want to start up again then?
Should we start at 1:15, 1 hour from now?
That's fine with me, and that should give everybody enough time. And they're not going to need the full hour for the exam, so there should still be a little bit of time for them to, eat. So should we say?
Yeah, an hour from now is where we need to get back. So
okay,
let's
so
start by 1:50.
Okay, so 1 hour.
So in the afternoon session, how much time we have the training till evening or?
No. So the afternoon will just be an hour. We're just going to be doing a workshop today. So much shorter.
But guys, I would suggest you take the exams now. And if you have any queries, we are available so we can help you in your certification. And then you can grab the lunch. So
yeah, and thank you for mentioning that, Poonam. Certainly, if you do have questions, we can help. We won't give you the specific answer. Well, sometimes we do, but we will at least help you. And certainly, if you find there's issues with the exam, also, of course, please let us know. Okay, very good. So I'm going to put myself on mute. Suresh and Poonam, I assume we'll kind of rotate in and out here to take a little break, and then we'll get back together and in about an hour. Hour and a half, right?
Yep.
Okay. Very good. Thank you, everybody, and we'll talk to you shortly. Okay, very good. So welcome back, everybody. Now we're going to continue with a workshop for today. So this portion is going to be an hour, so not as long as the morning. So let's discuss today's content. What we're going to be talking about is AWS observability, specifically using, as it says here, tracing and root cause explorer. So you may be familiar with those tools. I actually kind of hope you're not, because you'll get to see them today and experience them. Like in the morning portion, I do have some slides to go over, but then we will get into labs as well. So a little slide heavy in the morning, in the first portion of this section. But then the second half will be a lot more labs. So, all right, so let's dive in here. So as far as an introduction, we're kind of doing it. Going to talk about end-to-end observability and what we mean by that. I'm going to talk specifically about AWS observability and how Sumo Logic fits in there, if you will. And then we're going to look at finding and solving and preventing failures with RCE, Root Cause Explorer. And then we're going to look at tracing as well. So with Root Cause Explorer, we'll have an exercise. Tracing, we'll have an exercise. And then talk about just next steps. And that will conclude today's session. This slide you saw already, so I don't really want to go over it again. Just as a whole, it's just, once again, who we are, where we can help, And today we're really focusing on observability. So hopefully you're familiar with Sumo Logic. I feel like you are if you've attended today, and you're comfortable with us as a company and how we do everything. And we have certifications and all that stuff. So yay, Sumo Logic. So let's go straight into end observability. Save a moment on that other slide. Now, first, I wanted to talk about the difference between monitoring and observability and look at the definition so that we're all on the same page. A lot of people equate observability to monitoring, and of course, there's similarities and threads throughout them, but there is a little bit of a difference. When we dig deeper, it's not just about seeing when something is wrong, but about what is causing it, what areas it's impacting, and how we can correct it before it impacts either more customers or more parts of the application. So how are they different? Monitoring is about telling you the state of a system by looking at parts that have been configured to be monitored. If a part of the system isn't monitored and hasn't been configured to be monitored, then we have no idea what's happening there, and knowing something is wrong is important. Observability goes beyond monitoring by bringing together the logs, the metrics, the traces to give us a broader view and a deeper context. Knowing something is wrong and being able to find out why. And it's that why that is critical. I was going to say more critical, but it's critical. All right, a couple of slides here. Now, observability requires more data and richer analytics as you go from an alert to the problem resolution. Let me go ahead and get these loaded on here. So there's two key requirements for an observability solution. I alluded to them just a moment ago, but they are the fact that first, the observability solution should be able to handle large scale data sets. While monitoring and diagnosing requires working with some amount of data, it's the troubleshooting phase where the observability system should be able to handle unlimited amounts of data from logs, metrics, and traces. And this is a challenge for many observable solutions that don't have a high-end and highly scalable solution. Well, fortunately for you and for us, since we were built on cloud native architecture, Sumo Logic enables the ingestion and storage of any amount of data in a highly elastic and flexible way. The second requirement for an observability solution is that it needs to have a very scalable analytics engine. Observability requires you to analyze lots of data to machine learning and other initiative search-driven analytics capabilities. As a large-scale machine data analytics platform, Sumo Logic provides these out-of-the-box capabilities to support the ingestion and analytics of any amount of data. So in this graph, or this chart rather, what we're showing here is the idea of an iceberg. And at the tip of the iceberg, you have that what. That's going to be found through logs. And the what is very helpful. The what is important, but the what isn't the whole story. To get the what, so in this case, what went wrong, you can monitor the system. And to do so is going to require about 20% of your data. But as you go deeper, as you want to start to get into the where, and more importantly, the why and the how, you need more data. More data also requires more sophisticated analytics. And that's what we're showing here is the fact that Sumo can help you with these things. So we're not really going to focus on the step one of monitoring, the what. That's pretty easy to do in Sumo, and we have classes that discuss it. But what we want to focus on is really the where, the why, and the how. So we're going to do the where through tracing, which we'll do shortly. And then we're going to look at the why and the how through the root cause explorer, which also we'll look at shortly. The numbers here, it's not super important that you know each number here, but it's the idea is that as you want to get deeper into a problem, into an investigation, you need more data, which, I think makes sense.
Josh,
yes.
Sorry.
No, go ahead.
I just want to kind of even in the previous morning session. So I mean, if I look at this PPT, okay, so I kind of feel like it is a reactive, okay, like something happened and we are investigating and we're trying to understand why it happened. Okay, it is good reactive, but how it is going to be turned into a proactive to prevent future. Okay, so I mean, so in the Sumo Logic, okay, I mean, after this session, you can, if you can cover, okay, how we can prevent future by taking any kind of advantage of ML concepts. Okay, so such availability is there, so probably you can cover that after this session. Do you think that makes Do you think that useful?
So that's a fair point, is that we are talking about more, I guess you could say reactive. And so there are proactive methods through the machine learning, through using outliers, setting up monitors,
Yeah,
things like that.
prediction, and
Yep.
then we're writing rules and actions for that predictions. Okay, before something. So with that, we are gathering this data to anticipate the future. Okay, so all this is going to be turned into knowledge base and then become a anticipation for the future and prediction, so that it can be turned into future actions. Correct? Okay, so I mean, I'm not talking about the current session. Once this session is over, if you have something to show on that level also, could be very helpful. I'm just
No, that's good. Good
Sorry.
feedback, and it's a valid point. Yeah, it's a fair description. So,
Anjanaya, we have some operators which can actually help you to predict things rather than being completely reactive. You can tell us some sort of examples and we can actually show you some things that we have in the system as well. For example, we have a predict operator. So the predict operator will tell you like the future values based on the past trend that we observe. Like, for example, when are you going to run out of disk, right? Or if the same rate at which the disk is actually getting consumed, you may run out of storage, etc. So predict is one operator that you can use. We also have something called as a log compare. The log compare basically compares your current environment versus a baseline, and it can tell you if something is actually changing. So that way you can actually keep track of changes, because changes are the one which cause a problem. So then you can monitor it and then go and check your critical system what has actually changed. So these are a couple of operators that we have that can actually help you to get proactive rather than being completely reactive.
Yeah, understood that. I've understood that. Okay, so probably if we cover that as after this session as a small component, that these are the proactive measures we can cover, so that it'll be a complete package. That's what I just my opinion. Okay. Yeah, thanks.
all right, let's go ahead and continue. So this next slide, very similar to the previous slide, but talking about end-to-end reliability and now bringing it into a unified observability platform. So on the left-hand side of the screen, what we're showing are all the different sources, or not even sources of data, but all the different environments that might be generating data. Data might be coming from your hosts, be coming from your servers, of course, your applications, components, AWS, Kubernetes, et cetera, et cetera. And so it's required to have all the relevant data, such as these metrics, logs, traces, that metadata, in order to put the data, get the data into the system, so that we can then monitor, diagnose, and troubleshoot. So very similar slide as the previous one, but once again showing these monitor, diagnosing, troubleshootings that are really going to help us start to detect, and that monitor is the prediction, things like that we were just talking about. Those operators are great for the monitoring, then help us understand when something went wrong and troubleshoot. Now, who can benefit from an observability solution? Well, everybody can. Certainly SREs and the DevOps team, those individuals that are responsible for monitoring the health of an application, they're going to need observability so that they can quickly monitor, diagnose, and troubleshoot the application health issues. Observability is going to help the software engineer on the team by providing visibility into that software pipeline. By collecting information about the pipeline and identifying the issues with the software delivery process, those teams can improve the quality as well as the delivery of their application. And then security teams can ensure the security posture of their applications through observability. And what's great about Sumo Logic is and unique about Sumo Logic as well, is that it addresses the needs of all these teams and personas in one integrated platform. So a little bit more about this. Oop, keep clicking too quickly. There we go. Similar slide as the others, once again showing on the left-hand side of the screen, monitoring, diagnosing, and troubleshooting. And then what we're showing in the center of the screen are the different tools, I guess you would say, within Sumo Logic that you might start to use. Or not tools, I guess, but as you start to drill down. So once again, monitoring, very easy to set up a chart, set up a graph that's going to turn a certain color, or send an alert when something goes wrong. But as we want to dig deeper into things, we need to go in deeper into the data. We need to get into the deployments, get down to the cluster level, ultimately to the pod level, and then components. And we're going to discuss utilizing root cause in just a few moments. This is I like this slide. We're only going to really use one portion of the slide in here. But what we're showing here is, as it says, advanced analytics by observability workflow. And that actually speaks to what we were talking about earlier with some of the monitoring features. So in regards to the monitoring, using the outlier analytics, excuse me, hard for me to say. Some of the predictive analytics are certainly going to be helpful for, as just discussed, to detect when things might be failing or succeeding, depending on what the case may be. Now, what we're going to be focusing on today here is the troubleshooting phase or step, and specifically the far right option of the root cause explorer. So while we do have these other options, not options, features that are advanced analytics and operators to assist with observability, today we're really focusing on that root cause explorer. And as the question was alluded to earlier, we probably should, we kind of allude to the monitors in various classes, but we don't have one dedicated to it, which is probably would be helpful. But so we're going to be going over that root cause explorer today. All right. So now I wanted to talk specifically about Sumo Logic and AWS and that observability solution. We had been talking previously about Sumo Logic. We talked about observability, and now we're going to use AWS. Observability can work for more than just AWS, but for this portion, we are using this as the example and probably the most common use case. So AWS, as you know, or may not know, encourages the use of separate accounts to help manage costs and give teams independent administrative control. Additionally, different accounts often have different settings across regions based on the needs of a specific app. Once you're in a certain account and a region, there's multitudes of services that customers can use to run their apps. And within each service, there's even multiple entities or instances that correspond to their own. The problem with all this is it creates a very complex hierarchy, which often leaves vast data silos, where it can be difficult to acquire a clear picture of overall AWS service health across the regions and accounts. So what we found is that our customers, you guys, have many accounts in AWS across many regions, and across those many regions, you're using many different services. So you might be many different regions and using the EC2s and the S3s and all these different components of AWS across different environments. And the challenge is, as you've told us, is the visibility. How can you see across those accounts, those different regions, those different service hierarchies, what's going on in your systems? How do you do that? Well, fortunately, Sumo Logic can help with that. And because you have these hierarchies and these data silos and groupings in different regions and all that, it just makes troubleshooting very complex because there's different things going on in different areas and different regions. And so what we wanted to do is make, or from that complexity and chaos, show clarity and root cause. So on the left-hand side of the screen, what we're showing is what you're probably kind of familiar with. Applications moving to the cloud at an ever increasing rate, and this new challenge in observability are presented. With what we see on the right-hand side of the screen is, once again, this clarity that Sumo Logic can provide. Using the AWS observability as well as root cause explorer solutions, we can break down those data silos and help drastically reduce the time it takes to identify and troubleshoot issues with your application by giving you a topological understanding of your AWS environment across multiple accounts and regions. And so we're going to go ahead and take a look at that now, really. We're going to dive in pretty quickly. So we'll get some hands-on experience of what I was referring to earlier. So before we do, let's go ahead and let me do a quick little demo, actually. Let me talk about this screen, I'm sorry, and then I'll go into the system and we'll do it together. So this is what Root Cause Explorer is going to look like. It may look very busy from what we're viewing, but we'll get into it and understand what's going on. But essentially what it's doing is it's showing us different events that the system has determined to be interesting, and they're called events of interest, EOIs. And the system has marked them. and it's marked them as what type of issue essentially it's been having, as well as when it's occurred, and what we call the drift, which is the deviation from the norm. So what we see here, for example, this red, all these red clusters are letting us know that errors have occurred. It's letting us know when on the timeline it's occurred. So looking at the past 24 hours, or in this case, the past 3 days, we know that this happened an hour ago or 2 days ago. And on the y-axis, that is the drift. That's the deviation from the norm. So the lower the number, the more, or the lower the y-axis, the more normal it is. The higher it is, the more abnormal it is. Let me jump in. This screenshot's not very exciting, so let me jump into the system. Oh, you know, let's jump in together. Let's all go start to look at these. Actually, I'm thinking about this. Let me show this one more time. Let me show a little bit more, and then I'll jump in. I'm sorry, a little eager to get going here. So what I want to show is some of the interface, and you'll get to experience this in a few moments, but let me go ahead and just take the lead. What I want to show is first the observability view that we offer. We can see this by going into New and Explore. And what I see now on the left-hand side of the screen are my different, in this case, accounts. I have my production account, I have my staging account, my training account, my dev account. In your real world, you might have those, you probably have more, you might have different ones, but I now have my accounts right in Sumo Logic. They're there already. Now I can start to drill into these accounts and start to look at things. Now, once again, I guess the discussion earlier, this is more of a reactive approach, but still a necessary one. So for example, let me go into prod. And now I can select my region. Which region am I interested in? US 1, US 2? I'm going to go ahead and let's do US East 1 just to start with. And now I get an overview, while it loads, of what's going on. As we saw earlier, that some of that activity location information from the morning, we see that here. We see information about the resources that are being used, gateway information, ALB information, EC2, Lambda, et cetera, et cetera. Below that, or excuse me, back on the left-hand side of the screen, we have individual, in this case, they're considered to be they're called namespaces, but essentially they're individual services that are taking place. So if we want to, and we will shortly look at some of these, we can. So if we want to look specifically at Lambda, we can drill into Lambda. And now we're looking at, over the last 24 hours, everything that's gone on in our production US East 1 environment for Lambda. And this is a training environment, so some of this data doesn't load as nice as it should. Most of it does. But now we're starting to get that visibility, that observability into it. Now I want to go ahead and, like I said, we'll go ahead and take a look at this in a moment. And honestly, if you still have those credentials we used earlier, you could jump in now and start looking around. In fact, why don't we jump in together? Let's go ahead and do that. Let me put those credentials back up. Do it a little bit out of order, but I think it'll be more fun for everybody. So I'm going to put those credentials back on the screen. They're the same ones you used earlier today or possibly yesterday, depending on when you joined us. Just go ahead and log back in. You can use different numbers if you want than the ones you used this morning. It doesn't really matter too much. But let's go ahead and get logged in anyhow. And if you need help getting logged in, of course, please let us know. Once again, for the analysts, it's going to be number. So pick a 3-digit number. And then go ahead and log in, August 21 exclamation point. Once you get logged in, there we go. Once you get logged in, if you want to go to New and Explore, excuse me, that's going to get you into the observability view that I was just describing. And feel free to go ahead and kind of poke around in there. We're going to do a lab with this information in just a moment. So this is not, this was on the roadmap anyhow. All right, so we should be logged in. And we should go to New to Explore and just kind of start checking it out. We also have more dashboards under here. So lots of dashboards, and we'll view some of those shortly. But as I go into US East 1 or wherever level I go into, I can also view additional dashboards. And so I can start to view just more and more stuff. All right, now let's go. Let me go back to my slides just to keep me on track here with the lab. All right. So what we're going to do here, sorry about that. This slide, okay. So what we want to do now is we're going to go ahead and do a lab exercise using that Explore that we just looked at and get deeper. But we want to set a scenario for you for this lab. So what's the scenario here? Well, the scenario is that you're a DevOps specialist and you're supporting, as it says here, mission critical applications on AWS, specifically ELB, the application load balancer, host EC2, and DynamoDB. So those are your 3 areas of expertise. And what you find out, and this is your first day of work, what you find out is that end users are experiencing an outage in the application. They're getting 500 errors in the application, specifically in the US East 1 area over the last 24 hours. So you find this either from secondhand information, or maybe your manager told you, or maybe you get an alert through the system. This can be proactive, sending alerts that we're having a spike in 500 errors, but we need to figure out what caused them, and sort of equally important, what will resolve them as well. It's great to see what caused the issue, but we want to fix it. All right, so how are we going to do this? Well, we're going to use Sumo Logic, and we're going to go ahead and use the tools that we have available to us. So what we're going to do is we're going to go back to Sumo Logic, or I guess you still have it open. And we're going to go ahead and in the new Explore tab that we opened, we're going to start to drill down to the area that we want to look at, specifically production, US East 1, because that's the area that we are in charge of. And that's the area where we've been told things are not working quite properly. So now we're in US East 1. Now what we want to do here is we want to go ahead and kind of not cheating a little bit, but we do want to go down to the application ELB. And the reason we want to do is this is one of the areas that we're responsible for, one of the load balancers. So what we want to do is we want to go to the application ELB. And what we're going to see here, and what we're interested in, is the 500 errors. And so this should load. It might take a moment. So we want to go to prod, US East 1, AWS application ELB. And if I scroll down here, what I want to point out is this particular chart or graph, this 5xx by load balancer. What this is showing me is load balancer data for the last 24 hours, 500 errors. And what it's doing is it's showing me that they're normally pretty level. There's some that have a lot of errors, there's some that have no errors, but they're at least pretty consistent in their amount of errors. Since this is a training environment, there's going to be some repetition of that data. But what we notice, or what I want you to notice, is right here, there are spikes. There's 2 spikes. They are for me, they're 6 a.m. and 6 p.m. local time. For you, they're probably 6:30 a.m. and p.m. local time, but you should see spikes regardless, because they should be in the last 24 hours. So what we're seeing is that there are some spikes related to the 5xx load balancer, the 500 errors. We don't know what's causing them necessarily, but we do start to see them in here. So what we want to do now is we want to figure out what's causing these errors, what's causing this spike in 500 errors. We figured out the why, or the what's going on, but we need to figure out why these are occurring. What we're going to do now, where is it? Is we're going to go up to the very top of the screen, and we're going to choose the events of interest option. It doesn't really matter which one you choose, they're all the same. We just have rep duplication because it's, once again, a training environment. So any of them should be fine. And what we're presented with is, it's not truly root cause explorer. It's like a mini version of root cause explorer, but it's essentially root cause explorer. What this is starting to show us here are those errors that we were just talking about. So what I see here at about 6 o'clock local time is errors represented by red. I see the x-axis and y-axis giving me the time, as well as the fact that these are abnormal. They're very high on the y-axis. If I click my mouse on them or just mouse over them, either way, what I do is I get some information about them. So what I see is that they are ELB app errors related to Sumo Logic, of course, related to US East 1, and they're the 500 errors. If I scroll down, I get a chart here. And this chart is showing me metrics. What this chart is showing me is metrics related to the ELB 5XX count. And what it's showing me is the fact that blue is representing today, green is representing yesterday, and light blue is representing a week ago. I see the green and I see it's pretty level. It's up and down, but it's at least pretty level. I see the light blue is pretty level. But what I do see is this blue, and what it's letting me know is about 6:30 or so, there was a spike in 500 errors. The spike continued for about 15 minutes and then it dropped. So now I'm getting some more confirmation that there's something with these 500 errors, this time period, this is an anomaly. And now I need to keep digging deeper. Now we're going to show you how to do so in a moment, but now I want to go deeper. I want to figure out what caused these things. So how am I going to do that? So before I continue, and we're going to now dig into the Root Cause Explorer to look for that error or that issue. Any questions so far? All right, let's keep going. I assume there are some questions. That's why I asked. But let's finish up this exercise, and then we'll answer them, because I think we'll answer some of the questions on the way. So what I want to do now is I want to go into my Root Cause Explorer. This Root Cause Explorer, this is like a mini version. This is isolated just to the criteria I selected, which is okay, but I want to go to the bigger version, if you will. So what I'm going to do is I'm going to go up to New, and I'm going to go to Root Cause. And what this is going to open is the true Root Cause Explorer. Very similar to the screen you just saw, but a little more robust. And what I want to do here, or before I do anything here rather, what this is showing me is all the different events that are taking place that the system has noticed as being kind of odd. I can mouse on any of these and start to see them. As we see here, some of these are not related to things that we're interested in. So we're going to start to filter some of this out. A lot of this we're going to filter out very quickly, but we do start to see it. To filter it, we're going to go to the top of the screen and we're going to click here to add filters. And now we're going to specify the filtering that we want to do. In this case, we're going to go ahead and use the AWS information. So we're going to specify the prod. We're going to specify US East 1. And then we're going to, oh wait, let me see, why don't I have my data here? I'm missing the data that I need. Why is it not here? Oh, let me do a longer time period. There you go. So I apologize for that. So you're going to want to do the last 24 hours in the Root Cause Explorer. By default, it's going to do the last 3 hours. And we want to go further back because we want to go 6 a.m. or 6 p.m., about 5 hours ago. So we're going to do last 24 hours. I'm sorry. We're going to do prod. We're going to then do US East 1. And then what we can do in the namespace are select those namespaces that are relevant to us. So we're going to select, we really don't need the Lambda one. So we're going to select the DynamoDB. We're going to select the ELB app, and we can select the host one as well. Now for this exercise, we don't need the Kubernetes data or the application service data. This is more just training data that we just don't need for this exercise. So we can go ahead and on Kubernetes, turn that off, and the application service, turn that off. And what we're left with, hopefully, are 3 data points for each 12 hours. So we're going to look at these just as a grouping of 3 together. So once again, we're in Root Cause Explorer. We did the last 24 hours. We want to make sure that we're not using the Kubernetes data or the application services data. And for the AWS data that we're using prod, US East 1, and for the namespaces, select host and DynamoDB and ELB app. And I hope we're all together for that. And what we're left with, like I said, is we should have 3 points here. These other 3 points we can ignore, they're just repetition. But what we should be seeing here is now a root cause of what happened. And let's go ahead and see if this tells us any story. We're going to look at this red point first here. This red dot, when we mouse over it or click on it, we see that it's that ELB error, that 5xx count, that thing that we've been looking at for a long time. So we see that 5xx count. But the goal here is to figure out what caused it. These 500 errors didn't just happen on their own, although they kind of did, but something had to kick it off. So what happened? Why are we getting these 500 errors? Well, what Root Cause Explorer is showing us is prior to these 500 errors, there was a bottleneck that occurred. And this bottleneck is related to prod US East 1, and particularly it's a CPU load average. So prior to us getting 500 errors, the CPU spiked. The load average went up very high in an abnormal way. I was going to say a weird way, just an abnormal way. But what happened before that? What we see happen before that is a DynamoDB issue. There was a bottleneck there. Specifically, the read throttle events spiked as well. So now we're starting to get a better story. For some reason, and we'll figure out that reason, but for some reason, DynamoDB bottlenecked and spiked the read throttle events, which resulted in a CPU spiking. The CPU was overloaded, and as a result, a bunch of 500 errors occurred. And so that's where we're at so far in our kind of our little story here, if you will. But now we need to go a little bit deeper. The deeper part we need to figure out is what caused that spike. And so what we can do is we can try and figure that out. So let's go ahead and try and do this together. I'm hoping this lab works. It usually does, but I'm nervous, but let's go ahead and figure it out together. What I'm going to do here is I'm going to go ahead and click on the DynamoDB bottleneck. And on the right hand side of the screen, I'm going to select the infrastructure tab. And then I'm going to choose this open in option, and I'm going to choose entity dashboard. Basically what this means is I'm opening up this information, this specific view in the Explore tab. So I found my events of interest. I found this DynamoDB is suspicious or interesting. And now I want to kind of zoom in on that. So I'm going to select open in entity dashboard. And what it's going to present is now that Explore tab, like I mentioned, but specifically going to the DynamoDB, the proper even table name within Sumo Logic. And I see that all here. Now, what I can do here is go to the events. What I want to do this for is I want to go into my events to see what happened. That DynamoDB didn't just spike on its own. Something caused it. And I want to see if I can figure out what. So I'm going to go into the DynamoDB events. Doesn't matter which one. And what I'm going to see here is some information about DynamoDB and some events that have taken place. Specifically, what I'm going to see here is this error. What I see happened is Ankit earlier today updated a table, but he updated it incorrectly. He made a mistake with the error with submitting the provisioned amount. He put a -1 as a provisioned write throughput write capacity. That failed. When it failed, it caused a spike in CPU. And that causes that increase in CPU resulted in those 500 errors. And so what we're able to see using Root Cause Explorer is that story that just took place. So let me go back to my slides here. So we identified the spike by using the observability dashboards. And we could have had a monitor in place to let us know that there was a spike there. In this case, we were using kind of secondhand knowledge if someone told us there was an issue over the past 24 hours, but that could be generated through Sumo of an alert, an email, some sort of notification. Then we went into the dashboard and looked for that spike, that specific issue that was relevant, the 500 errors. And then what was causing the outage was we utilized RCE, the root cause explorer. We found that 500 error count. We used the context and connections, the various filtering. And then the root cause was that rethrottle events was entered incorrectly. Ankit put the wrong value in there. And so RCE encompasses really 5 concepts, and we saw them just a few moments ago. The abnormal spikes, that's certainly a big feature of RCE is looking at those spikes. The system just using the machine learning, using the algorithms, using advanced analytics to look at things and see what's normal, what's not. Using time range is certainly important. So context and correlation, when did those spikes happen in relation to other events? The connections between the resources and services. So they're using the root cause to see, oh, something happened in DynamoDB, and then as a result, it messed up something in the ELB environment, which they are connected, of course, but we can see that connection through RCE. The earlier spikes letting us know, hey, something happened, then something else happened. Well, going back to those earlier things will help us get a better figure out what caused the issue. As we know, things happen or don't happen, but there is a cause to them. Someone made a human error, a system error, whatever it might be, and our goal is to find that cause and remedy it. And then the associated log exploration. We didn't get too deep into the logs, but we were starting to see that log for Ankit that he updated that table improperly. All right, so any questions about RCE? All right, let's go ahead and continue with tracing. So with tracing, we're going to go ahead and do some hands-on exercises as well. I do have a couple slides to set the table as well. So let's go ahead and talk about those. Oops, too fast. So for our tracing example today, we're going to use a fictitious company called Sumo Logic Coffee. At Sumo Logic Coffee, our goal is to deliver a hot, fast cup of coffee. We have locations around the world, very similar to a company that has a green logo. But for today, we're a blue logo and we're Sumo Logic Coffee. Now, how is Sumo Logic Coffee relevant to observability and technology? Sumo Logic Coffee, you go, you order a cup of coffee and you drink it. It's pretty straightforward. But it's not. There's more steps there. And that's what we want to talk about now and use this analogy. Actually, not this analogy, this example, because we're going to look at this in Sumo Logic in just a few moments. So when you go and order your cup of coffee, what happens? Well, first, you're going to place an order. You might use the app. In fact, you will be using our app, or you might do it in person, but you go to the store, you place an order. The order is going to go to the barista. So the barista is going to get that order, and then he or she is going to start to process that order. In this case, our coffee machine does a lot of the work. So the coffee machine is going to check, does it have the right amount of ingredients? Does it have coffee beans? Does it have water? If it does, it's going to brew that cup of coffee. The coffee is going to be ready. And before we give the cup of coffee away, we want to charge for it. We have to get paid. And so the customer is going to pay for the order. The credit card, in this case, we're going to assume it's credit card transactions, is going to be approved. And then the customer is going to walk away with their order. And so in that respect, an order and each step is essentially a microservice. This takes place, this takes place. And what we're going to do with tracing is start to look at those microservices, look at those steps, and start to see where things might have gone wrong and why they went wrong. And that is what we're going to do. So we're going to do that in the lab in a few moments. Now, before we do, what does a successful order at Sumo Logic Coffee look like? Well, this is what it looks like. What it looks like in real life is somebody goes through those steps that I just described and leaves with that hot cup of coffee. But in the back end, from a technical standpoint, this is a successful order. Now, what is this showing us? Well, what it's showing us is a trace. It's showing us the transaction essentially. This is an example of a successful transaction. The reason I know is well, a few reasons I know. One, it has a 200 status code, and we're going to use status codes today. We're going to play around with them. The other thing is that there's no red in here. You'll see horizontal red lines to indicate something is bad. But what we're seeing in here is a lot of different information. We have the trace ID. So this is starting to give us like a transaction ID, something that we can look at specifically, and they're going to be unique. No IDs will be the same. We see the various services. So the cash desk, for example, responsible for the payment of the transaction. We see the coffee bar, which is responsible for some of the ordering portion of the transaction. We see the machine service representing the machine, the actual physical coffee machine and the work it does, and so on and so forth. On the top left, we also see the time. So we see the time this order started or was submitted, and we see the duration, in this case, 121 milliseconds. It's a very fast cup of coffee. And then down below, we start to see those services, or really those microservices, broken out. And we're going to look at those in more detail in a moment. Now, status codes are going to be important for today. 200s are going to be good status codes, and we just saw one. We probably won't look at one specifically again, but what we want to do for today and today's exercises is look at some of the other status codes and try and figure out what is causing the issue. And so that's what we're going to start to do right now. Once again, go ahead and log in. I'm assuming everybody's logged in. You can ignore these credentials. The credentials that you're using currently with the August 21 are still correct. So I'm going to assume everybody's logged in. And what I'm going to do is, as it describes right here, I'm going to go to new and I'm going to go to traces. So I'm going to log in, or hopefully still logged in, go up to new and go to traces. And what I'm presented with is the tracing environment, or the tracing environment, I guess is a okay way to describe it. What am I looking at on this screen? I'm looking at the trace ID, that unique transaction number, or in this specifically trace ID, that's what it is. I'm looking at the root service. We're going to modify this in just a moment, but this is starting to tell me the main or service that's being utilized. In this case, like with previous data, this is training environment data. And so a lot of this root service we don't need. So we're going to filter some of this out in just a moment. We see the root operation name, what occurred. Let's go ahead and filter this though, because this has much more data than we need. And the filter we're going to use is service equals the coffee lover, and we're going to do it for any span. I'll paste this into the chat. Oop, let me see here. This might have changed recently. Service equal the coffee lover for either one should work. Let's see. Why do I not have data? Let's figure this out together. Oh, we have changes. Okay, let me slow down here. I'm sorry. This is a little bit new from the way it should look, but we can still work with it. What we want to do here is we want to do the root service is the coffee bar dash front end. So let me do this, and I'll add it to the chat. So we're going to go into traces, and we're going to do service equals the coffee bar front end. And we can do that for any span. And let me see. Actually, this is a little different.
For the coffee lover, I get data for when I choose 7 days, last 7 days.
All right, let's do that for now then. Yeah, that should, so what happened, it's an internal issue. We changed our data sets and somebody did it a little bit ahead of telling me. So let's do that. Thank you for pointing that out. Let's use the last 7 days. And let's do the service equals the coffee lover for any span. So I apologize for that, but thank you for pointing that out. So we're doing traces service equals the coffee lover for any span and past 7 days. And what we see here as described and really a little more properly formatted of what I was expecting is we see our trace ID, we see the root service. But what I want to focus on is on the right-hand side of the screen, the status column. And I want us to go ahead and sort by statuses. So with my statuses, I should see it some 200s. I don't know where they went. There they are. My 200s, those are successful. We kind of talked about those. But what I want to do is I want to start to look at some of those that have errors. So what I want to do is I want to look for a status, and it might help to just flip your status column around for a 503. So what we're looking for is a status of a 503. There's going to be 402s, there's going to be 502s. We will use those shortly, but let's look at 503s just to start with. And with the 503s, I want you to select one of the 503s. It doesn't matter which one, they all should be the same. Not the same, but similar. And what I want to do is click on it. And what I want to do, or what the system is telling us, but I want us to look at, is what has gone wrong here. What does a 503 mean? So let's go ahead and figure out what a 503 means. What we see here is red horizontal lines. We also see that it says 8 error spans. So this is letting us know that there's an error here. There's a problem with this transaction. The person did not get their cup of coffee properly. Where was the issue? Well, what we can do is we can look down at the lowest level where there is a red line, and that's going to give us an indication of where the issue was. So what we see here is this horizontal red line, and the lowest level where there's a red line is this blue box. If we mouse on that blue box or click on it, we're going to see some information about what has gone wrong or where things have gone wrong. So this is related to the water service, specifically the operation of getting water. So what has happened here? Well, what we're going to do here is we're going to look at the logs to try and figure out what has gone wrong here. So we're going to open the logs. We can do the span ID or the trace ID. The trace ID is going to give us more information, and I'll probably do that for this example. And so what has gone wrong here? Well, we see an order was received for coffee, and we want to read this from bottom to the top. We see an order was received for coffee grains for 40 coffee. For 40 coffee grains were needed for the order, excuse me. The coffee grains in 40 were provided by the machine. Then the machine received the order or needed the order of 1 milliliter of water to fulfill the cup of coffee. Well, here we see what went wrong. There was not enough water in the system. And so that's why the error occurred. So what we now know is a 503 is a cause of not enough water in the system. So if we go back to our traces, we now know, and we can look at any of them, all these 503s mean there's not enough water. Now, what do we do about that? I don't know. We might build bigger water reservoirs on the machine. We might have our baristas be trained to check the water levels more frequently. But now we're starting to be told that these orders could not be fulfilled because there was not enough water. Now, what I want us to do is go back to the same screen, the trace screen, and I want us to look at a 502 and figure out what a 502 means. So I'm going to select one of the 502s, and I'm going to look or notice the red lines, and I'm going to look for the red lines at the lowest level. I'm going to click on it, and what I see here is it's not related to the water service. That's not a problem here, but it is related to the coffee service of getting coffee. And so what I can do is I can open up the trace ID or the span ID. The span ID is just going to give me this little box where the trace ID is going to give me everything. For this one, I'm just going to do the span ID just to show the difference. And what I see here is what has gone wrong. Info received order for coffee grains 2. So the system needed 2 coffee grains to provide the order. Error, lack of coffee grains, an amount of 2. So using tracing, we now know what has gone wrong, where it's gone wrong, and why it's gone wrong. I think I might have said where and why, how. We got a bunch of the WHs, the who, what, where, why, and hows. Now we have one more here that I want us to look at. And if you know the answer, I'll go, that would be great. Go ahead and answer in the chat. But what I want us to do is look at the traces and look at a 402 and see if we can figure out what a 402 is showing us. What happened with this 402? Why could this order not go through? Once again, the 502 was coffee, 503 was water or lack of such. What happened in a 402? So if you know, go ahead and put in the chat, and now let's go ahead and take a look at it together. So I'm going to look for one of the 402s. It doesn't matter which one. I'm going to open it up. I'm going to look for the red horizontal lines, and I see them, but I don't see them related to the coffee preparation anymore. And so what this is telling me, it's not related to that portion. What I do though see is the red line is related to this green, particularly this pay in. I know the green just by the color scheme or color coding is related to the cash desk. And so that's letting me know something with payments, something with the transaction payment side of things is not quite right. But now I can go ahead and figure out what it was. So I can go ahead, click on that pay in portion that's red. And now I can go ahead and I'll use the span ID again, just it's a little bit easier. And if I go to the very bottom, I start to see what has taken place in this transaction. So here I see payment is in progress. Somebody ordered a couple espressos and we're starting to calculate the price. We're getting the product price. The system is querying the database. It's calculating the total price, doing more calculations of verifying the price and the order. So this person ordered 2 espressos. So it's taking the espresso multiplying by 2. And then what happened is the person did not have enough money in their account. So very simply, it's kind of not simple for them, but they didn't have enough money. And so the transaction could not be completed. And so that's how we can start to use the traces to start to get an indicate, well, many uses, but one of them is to start to look at these transactions and see what has gone wrong. Or what's gone right as well. So we could look at these transactions and look at the ones that were faster and start to figure out why were they faster, which is good because our goal is to get that cup of coffee out quickly. Let me go ahead and jump back into the deck here. And thanks for working with the that issue, that tracing data, that 7 days. Thank you for just being patient with that. Cool, so we went through that. Now, the last thing I want to talk about, and we don't have any labs on this, and we should going forward. One, it's this class is just pretty full of the workshop, but is that unified alerting? We've alluded to it, but we haven't really discussed it much, and we're not going to go too deep into it today, but it's very thoroughly documented. But I did want to at least show it both from a slide standpoint, and then we'll jump into it in Sumo as well. But the unified alerting is an important portion of Sumo logic because it does, as starting to allude to and ask about earlier, it does take things and makes it a little more proactive in that you're getting information about what's occurred, helping you with decisions as well. And the unified alerting is different than what it used to be. So I don't know if depending on how long you've been using Sumo, this feature has improved greatly. What you can do here is basically, as it shows, set up alerts in a unified environment. The alert types can be pretty varied as far as what type of alerts you want to set up. So you can set up an email, which is the most common, let somebody know when something went wrong. You can use webhooks, so you can set up communication via Twitter or Slack or Discord or many other communication properties. Script action, you can have a little script run even. And then a ServiceNow connection of having integrating with ServiceNow, which if you're using is a nice nice integration process. But let me go ahead and just show just at least quickly from the UI the monitoring. So if I go into manage data and alerts, we have monitors, and to set them up is very easy. We would provide first the type of data we're looking at. So are we looking at logs or are we looking at metrics? We can then decide on the static or the outlier, and this is right away going to help you with this proactive approach. Static will, well, still could be proactive, but it might not be. So with static, you might say, if I have more than 20 20 errors in 5 minutes. I'm trying to set this up. If I have more than 20 errors in 5 minutes, go ahead and alert me. But with the outlier, what you can start to do is use the outlier feature, and we looked at it briefly earlier, and have the system start to let you know when things are wrong or right based on what it's previously seeing. So rather than relying on a hard number, it can be more dynamic. And as things go up or down, you can say, let me know about this. And so it can show those more, those peaks or those valleys, depending on how aggressive you want to be. And then you simply just decide, who do you want to alert? So once you have the rule set up, the notification. So who do you want to email? And then you can provide a format here and then save it. And so this is a much easier system to do so, to create alerts. So I did want to point it out. Unfortunately, well, I mean, that's going through it, and setting them up is pretty easy. You would just put your query in there. But I will add something with alert and labs going forward. It should be involved in this class, or even the other one we did this morning. All right, let me go back to my slides. I think that's just about it. Summaries and next steps. So as talking about, we went over the AWS Observability, root cause explorer. We didn't go too deep into log exploration with root cause. We should have, but that's really another kind of tenet of utilizing Sumo. And then, although I think actually some of these links have been pasted into the chat while I've been chatting, let me go ahead and throw a few of these in as well. So certainly if you have more, want more information about our observability solution, or specifically AWS observability solution, the link I just put in is good. This one for traces is good, good for tracing information. And I think I thought someone put in one for root cause explorer. I think Suresh did. Right, so that covers the content for today. Questions?
Does these AWS observability apps, using them, does it put some cost on the organization, or are these part of the existing contracts?
I'm going to defer to Suresh, but it shouldn't. The apps we're utilizing are really just dashboards and queries that are being overlaid. So yeah, Suresh, if you know more about pricing, but
yeah, sure.
Please.
So the AWS observability collects a lot of data and then centralizes it to give you the visibility. So as part of this, we'll be collecting logs as well as metrics, and the AWS observability has a good amount of metrics data collection to show you things when they go bad, etc. Right? So obviously, this is going to involve the data charges from the Sumo Logic side of it. The Sumo Logic solution is priced based on the amount of data that you ingest into the platform. It is measured in GB per day, like 10 GB per day, 20 GB per day, 100 GB per day, etc. And it also depends on how much metrics that we collect, like DPM, data points per minute, like CPU utilization, various different metrics that we collect as part of the overall solution. So depending upon how much data is there in your AWS environment, and depending on how much we ingest into the platform, you will be spending corresponding credits in the Sumo Logic platform. This is cost factor number one. The cost factor number two would be like if you are collecting any data, or if you are the elements that you launch for collecting data from the AWS side of it and sending it. If there are any elements which is involved, then there will be cost on those side as well. Predominantly, the AWS observability is there for a couple of applications today. I think some 8 to 9 apps or 9 different services are covered today. And AWS observability is going to expand further as we keep expanding our portfolio. More services are going to be added to that. Does it answer your question?
Yes. Second part of this is the traces and root cause explorer. Are these completely dependent on the AWS observability, or these can be combined with other normal queries as well?
The root cause explorer today, it uses the machine learning aspects. It automatically detects the events of interest, what Josh walked you through. So these events of interest are like errors, any drift with respect to number of the utilizations, bottlenecks, right? All those sort of things. So this is built specifically for AWS for now. I do not know whether is there a roadmap to build a similar sort of solution for Azure and GCP as such. But as of now, it is built, purpose built for with AWS in mind.
Okay, thanks.
And any other additional questions? Okay, then that will conclude today's session. Suresh, I don't know anything you want to add or next steps for them?
Sure. Thank you, Josh, for walking us through the certification program today. I know it should have been, I know it is early morning for you. Thank you for putting in all the efforts and walking us through the entire platform. And I also liked you showing us the root cause explorer, which is a great addition to any DevOps teams, any operational teams today, because this helps us to automatically find out root causes of the AWS applications, availability, performance, etc. Traces is another nice feature that we added recently, and thank you for walking us through that today. And I would like to thank all the audiences who came in here, who stayed with us, who have invested your time and energy on Sumo Logic. And congratulations to everyone who has actually done the certifications. We are trying to see if we can send a meal voucher for everyone who attended the certification. We are trying for that. Once we get some information, we will let you know. Otherwise, thank you very much for joining this session today. Thank you for being the great audience, for asking all those nice questions and then engaging with us in making this program a grand success. Thank you, everyone. I wish you a very good weekend.
Thank you all. Have a good one.
Thank you, Josh. Thank you, Suresh.
You're welcome.
Thank you all.
Happy weekend. Thank you.
Thank you, Poonam.
Bye, Poonam.
Bye-bye.